So hello everyone, welcome to Unacademy JEE English, and in this particular session we are going to talk about kinematics. We'll talk about the kinematics in detailed one shot, and we are not going to take any PYQ in this particular session. Don't worry, we'll take the examples, we'll talk about the examples, we'll talk that how we will proceed in this particular chapter. So let us discuss what we are going to cover in this particular chapter. So first of all, we start from the very basics. What is rest, what are motion? We'll not take too much time in the rest and motion. I'm just briefly explain what is rest, what is motion, and we'll go into the details of the motion, what kinds of motion we have to study. We'll talk about all those things. Then we'll go to the motion under gravity, what kind of motion under gravity. There are two kinds of motion under gravity, 1D, 2D, all those kinds we will take in this session. Then one of the most important things, graph. We'll talk all about graphs, what kind of graphs, what is the physical significance of graph, what kind of graph we can make, and one more thing, we can solve questions by the graph very easily. This is one of the most important things. Then we'll move to the two-dimensional motion, what kind of motion we can talk about, we'll discuss, don't worry. Then one of the most scoring thing, relative motion also. So this thing, motion under gravity, it is I should say one of the most scoring thing in this complete chapter. If you see the chapter, if you see the syllabus, or you just see the exam question paper of the 2024 or 2023, you will just notice that there are plenty of questions from the motion under gravity. So we'll just go slow, and we'll talk everything in this particular chapter. Okay. Let us start from the very beginning. What is displacement? This we have studied in our class 9th, 10th also. Okay, so hello everyone, hello. This session is going about like 4 to 4:30, or it can go up to 5 hours also. Okay, so don't worry, we'll talk about everything around this. Okay, so what is distance, what is displacement, we'll talk about everything. So suppose that we have just 2 points, point A and point B. Now we have to move from point A to point B. We have lot of paths, we have plenty of paths from point A to point B. We can go like this, we can go like this, we can go like this also. So these are all paths possible from A to B. Okay, these a lot of paths, I can say there are infinite number of paths possible from A to B. So these number of paths, these paths are called distance. This is called distance. So the distance is what? Distance is any path between point A and B, or any 2 points. So the path between point A or any 2 points is called distance. So any path. This is what? Any path. Okay. But there is another path which is the shortest path from point A to point B. Okay, what will it look like? It will look like something this. So suppose that if I name these paths, this is path 1, this is path 2, this is path 3, and this is path 4. So all these paths, we can say these are all distances. But there is a catch, that this path 4 is a shortest distance. Path 4 is what? Path 4 is shortest distance. This is shortest distance, correct? Shortest distance, and this particular shortest distance is called displacement. It is called displacement. Okay, so this is a major difference. You all know, I know that that you have studied in your class 9th also, that what is path, what is basically distance, what is displacement. Okay, so we'll just talk about the distance and displacement very, we'll go into the deep also. Okay, so we'll just simply say that any distance is denoted by x, or sometimes we denote our displacement also by x, and this is denoted by s. Okay, now we just know there are two kind of physical quantity, one is vector and other is scalar. So we'll just name those things. So our distance is a scalar quantity. It is a scalar quantity, but our displacement is a vector quantity. It is a vector quantity. Okay, understood. Okay, no problem. Okay, so if we have understood distance and displacement, then we'll move on to the speed and velocity. What is speed, what is velocity? You all know that speed is something which, if you are covering some distance in some particular time, it will show some speed. You have seen that speedometer in your bikes and cars also. So this just shows something kind of speed. What is it? We'll talk about it, don't worry. Okay, so speed is what we'll be first of all define basics of speed. So speed is nothing but speed is nothing but the rate of displacement or rate of change of distance, rate of change of distance. Yeah, we can write it as distance upon time. This was the basic formula you read in your class 9th also, but we will improvise it and we will derive or we will write some special formulas from our speed and velocity also. So we will just distinguish this speed into two parts. One is average speed and other is instantaneous speed. One is average speed and other is instantaneous speed. What are these things? Suppose that you are standing here in Bangalore. Okay, you are here in Bangalore and you have to go to Delhi. Suppose that the approximated distance is 2000 kilometers. Okay, and you just took suppose that 40 hours to cover this with your suppose that your car. Okay, so your time taken is 40 hours. Okay, so you have taken 40 hours to complete this 2000 kilometer. So we'll simply say that what is your average speed? So average speed is defined as the total distance which we have covered divided by the total time. So this is nothing but the average speed is defined as total distance upon total time. So in this particular case, what is the average speed? So average speed is nothing but 2000 kilometers divided by 40 hours. It will come up to 50 kilometer per hour. 50 kilometer per hour. Clear? It will come up to 50 kilometer per hour. Don't worry, I'll teach everything. First of all, I am covering the topics which are like something important for your mechanics also. Don't worry, I'll cover everything. Okay, so what I was talking about, that if we have traveled from Bangalore to Delhi, I have measured that my average speed is 50 kilometers per hour. But realize one thing, that is our speed is 50 kilometers per hour in every particular second. Like I've started the bike or car, whatever it is. So I just started, it is from the zero. Okay, then I accelerated, then I go on the highways. On the highways it is like 120, 140, 160, something like this. Suppose that there is some kind of, you just felt that I should eat something. You just stayed on any particular hotel or restaurant. You just stopped your vehicle. On that particular moment your speed was around zero. Around what? It was zero. Okay, so it was never constant like this, like 50 kilometers per hour. If you start your vehicle on 50 kilometer per hour and you just continue it up to the 2000 kilometer, then you will reach to Delhi in 40 hours. Clear? Okay, but this is not the practical case. We have to calculate the instantaneous speed. What is instantaneous speed? Okay, let us talk about instantaneous speed. Instantaneous speed. Or I'm talking about the velocity also. Why velocity? Because if we talk about the velocity, it is nothing but the displacement over time. This is nothing but the displacement over time. Okay, one more thing I want to add, that we had written that speed was equal to distance over time, right? Distance over time, and velocity I have written as displacement over time. Correct? Then I wrote the average speed. Average speed that was total distance divided by the total time. That was total distance divided by the total time. Similarly, we can write this average velocity also. That average velocity or we can write it like V average, that is equals to total displacement divided by the total time, total displacement divided by the total time, correct, divided by the total time. Now we are moving to the instantaneous speed or instantaneous velocity. It will look like something same, okay. So instantaneous speed or velocity. Now just imagine you are here in Bengaluru and you have to move Delhi, right? The distance was around 2000 kilometers. We took 2000 kilometers, okay boss. Now just imagine, what if I say that you have to calculate your speed, or your friend was traveling from Bangalore to Delhi, okay. Just imagine like this, that your friend was traveling from Bangalore to Delhi. Now you just call him and you want to take the information that where he is exactly on this particular instant, okay. What you will ask, that where are you? He don't want to like tell you that where he is. Then what you will do is that you will take the informations from him and you will just collect some data, and on the behalf of that particular data you will just realize, you will just know the exact position of your best friend or whatever it is, okay. So you will just say that where were you, or where will be you on that particular, you just have to, what was the time, total time was, if the he was traveling with the average velocity, then the total time was 40 hours, right? Okay, you just asked him that where were you on the suppose that 20 hours, where were you, question was where he was on 20 hours, he was on 20 hours. So he didn't told, you just wanted that data, that what he was doing on that particular 20 hours period, okay. So you just asked, where were you on the 20 hours, he didn't told you. So you just asked that where were you on 20 hours and 1 minute, 20 hours and 1 minute. So just he told that my speed was, or my velocity was, and on that particular moment was something like 60 kilometers per hour, 60 kilometers per hour, 60 kilometers per hour, 60 kilometers per hour. But if you have the data that his speed at 20 hours and 1 minute was 60 kilometers per hour, you can't predict that what is the speed at 20 hours. So you just took some another data that you asked that what you were doing on 20 hours and 0.5 minutes or 30 seconds, or 20 hours and 30 seconds. He told that I was traveling with 80 kilometers per hour, 80 kilometers per hour. So the accuracy on being on the 20th hour is more in this particular case rather than this. Agreed? Okay. Now, if you have to calculate his speed or velocity exact on the 20 hour, then you have to this domain. There is a period of 1 minute or 60 seconds. There is a period of 30 seconds. You just reduce this particular difference between this time, you will get to know what will be his position on the 20th hour. Agreed? Any doubt? Okay. So now you just reduce this time period. This is the time period between this 20 hour, or you can say 20 hour to 20 hour 30 seconds, right? Because you have to calculate on the 20th hour. Okay, to 20th hour and suppose at 5 seconds, you have reduced the time domain or the time range to the 5 seconds, and his speed was 100 kilometers per hour. So you will say that on the 20th hour, if on this particular time his speed is 100 kilometer hour, you can say that on the 20th hour his speed would be something like 100, but little bit there will be some like error. Okay, so reduce this time period. Just reduce this time period. Or we can say delta t reduce. Okay, what was the average speed? What was the average speed? It was a total distance or total velocity, total distance or total displacement divided by the total time. So total distance was suppose a delta x divided by the total time. So you have to calculate what we were trying to do, that we have to find the exact value of the velocity on the 20th hour. So on a particular instant, we have to calculate the value of the velocity. That particular velocity is called the instantaneous velocity. And in this instantaneous velocity, if you reduce the time period between any two fraction of seconds, then that particular average velocity changes into the instantaneous velocity. Agreed? Okay, so just reduce this time period delta t to very small, like it is tending to 0. Delta t is tending to 0, then your average velocity will change from average to instantaneous if you reduce your time. Okay, so delta t tending to 0, it implies that v average will change into the v instantaneous. V average will change into the v instantaneous. Okay, so now v instantaneous, we can write at it like this: v instantaneous, that is equals to limit delta t tending to 0 delta x divided by delta t. Correct? And you have studied in some your basic calculus that this function looks like something differentiation. This is what differentiation, limit delta, or you have studied like this, that limit delta x tending to 0 delta y divided by delta x, it is written as dy by dx. It is written by dy by dx. So it can look something like this, that this is dx, this is dx divided by dt. So this is a basic differentiation of your displacement or your distance with respect to time. Agreed? Okay, okay. Now we have all these things. We can write the velocity as well as our speed in the, or whatever it is. If he asks about something average speed or average velocity, instantaneous speed, instantaneous velocity, we can write all these things. Agreed? Okay, okay. Suppose that now I'll give you a simple example. Suppose that we have suppose that your friend is traveling something like his position is changing with time as a function of his position with changing with time is like 6t square. It simply means as the time is increasing, his position is also increasing. Okay, now you have to calculate his velocity at 2 seconds. Okay, so calculate v at 2 seconds. What we'll simply do, we'll simply have to calculate. If we asking at a particular instant, it means we have to calculate the instantaneous velocity. So what is the instantaneous velocity? Instantaneous velocity is simply dx by dt. Okay, what is the function of x? This is 6t square. Just differentiate with respect to time. 6t square. What it will give? It will simply give 12t. This is the velocity. Now we have to calculate the velocity at 2 seconds. Velocity at 2 seconds, it will simply come to 12 into what is the value of t? The value of t is 2. So it will come up to 24. And what is the unit of velocity? It will come up to meters per second if it is given in meter per second. If it is given in meter and it is in second, then the unit of velocity will be meter per second. Unit of velocity will be meters per second. Okay, okay. Any doubt? Are yes or no? Okay, okay. Let's move on to the next example. Suppose that it is given as that position as a function of x is given as something like 2x square 2t square plus 3t plus 6. This is the position as a function of time. Now you have to calculate two things here. First of all, you have to calculate what is the velocity at t is equals to 3 seconds. Velocity at 3 seconds and what is the average velocity in 3 seconds, and average velocity in 3 seconds. Average velocity in 3 seconds. So first of all, we have two things to calculate. First is velocity at 3 seconds. It means we have to calculate the instantaneous velocity. What is it? It is the instantaneous velocity. So we instantaneous, we know that dx divided by dt. It means it will dx divided by dt. X is the 2t square plus 3t plus 6. So it will come up to 4t plus 3. Now, what is the value of t? What t we have to put? We have to put the 3 seconds. So t is equals to 3. It means 4 into 3 plus 3. It means 12 plus 3, which gives us 15 meters per second. So at 3 seconds, the instantaneous velocity of this particular particle is 15 meters per second. 15 meters per second. Okay. Okay. We'll go slowly. Okay, so this is the instantaneous velocity. Okay, don't worry, I'll take another example. Don't worry, I'll take another example. Suppose that we have to calculate average velocity. Oh, in this particular example, we hadn't calculated the average velocity. Okay, now we'll calculate average velocity. Calculate average velocity. So what is the formula for average velocity? We simply know that the delta x upon delta t. Delta x divided by delta t. What is the time? T is equals to 3 seconds. So in first 3 seconds, we have to calculate the instantaneous velocity. Suppose that it started from the t is equals to 0. So at t is equals to 0, what is the position of that particular particle? So is this particle was at t is, put the t is equals to 0 in this expression. What is the value of x? What is the value of x at t is equals to 0? So this will be 0. Second term will be 0, but remaining is 6. So particle was at 6 meters at t is equals to 0. Now calculate the position of particle at t is equals to 3 seconds. Because we have the time range of 0 to 3 seconds, we have to calculate our average velocity in these 3 seconds. Okay, so at t is equals to 3 seconds, what is the position of particle? Position of particle, put the 3 seconds in this expression. What it will come up? It will come up to 3 square plus 3 into 3 plus 6. Okay, 3 3s are 9, 9 2s are 18 plus 9 plus 6. Okay, it will come up to 27 plus 6 means 33 meters. If I have calculated this correctly, okay, 9 it's correct, 33 meters. Okay, so he started from the 6 meters. He traveled up to 33 meters. Now we have to calculate the average velocity in these 3 seconds. Okay, now average velocity I'll calculate on the next page. Okay, so at t is equals to 0, he was at x is equals to 6, but at t is equals to 3, he was at x is equals to 33 meters. Okay, now we have to calculate the average velocity. So v average, that is equals to delta x divided by delta t. What is delta x? Delta x means the change in position or the total distance covered or the total displacement. So it will come up to x2 minus x1 divided by t2 minus t1. Simple. What is x2? What is the final position? 33. What is the initial position? 6. So 33 minus 6 divided by, what is the time range? Time range is from 0 to 3 seconds. It means 3 minus 0. 3 minus 0 means it will come up to 27 divided by 3 means 9 meters per second. So just look at the difference. The instantaneous speed at 3 seconds was 15 meters per second, but in 3 seconds the average speed or average velocity is 9 meters per second. Clear? Any doubt? Any doubt up to this particular point? Any doubt up to this particular point? Clear? Okay. Okay. So this is the average velocity. Now let's move on to the next question. Let's move on to the next thing. First of all, that we have calculated the velocity or the average velocity as v is equals to delta x over delta t. Correct? Dx over dt. Okay. Now we just convert this expression into something else. This is the basic differentiation of x with respect to time that gives us the velocity. Now we'll convert this relation into the x is equals to what it will look like. Okay. Go from the basics. Just put this dt from here to there. V, or we can write it like dx, that is equals to v dt. Integrate both sides. Do the integration both sides. Integrate. integrate. This will give us the total position or the position change in position. So this will give us the delta x, that is equals to integration v dt. So if we have the velocity as a function of time, so if we have the velocity as a function of time, we can calculate the position also. We can calculate the position also. For example, we have velocity as a function of time as v is equals to 2t plus 3. This is the velocity as a function of time, correct? Now we have, oh sorry, okay. This is the velocity as a function of time. Now we have to calculate, suppose that it says that a particle started from the origin. What it says? Particle started from origin. Particle started from the origin at t is equals to 0, or started, it means t is equals to 0. Now we have to tell the position of that particular particle at 3 is equals to 2. Okay? So position of particle at t is equals to 2 seconds. Suppose that t is equals to 2 seconds. Okay, now we know that we have something which change, we have some expression which changes the velocity into the position. So we will simply write that delta x, that is equals to integration of v. What is the value of v? 2t plus 3 into dt. What is the limit of t? Particle started from origin at t is equals to 0, means lower limit is 0, and we have to calculate the total position covered in 2 seconds. So just upper limit is 2, just integrate it. 2, the integration of t is t square by 2 plus 3, the integration of 1 is t. So just put the values, put the limits, 0 to 2. What will come out? 2 cancel, t square means 2 square is 4 plus 3 2s are 6, means 10 meters. So what is the distance traveled in 2 seconds is 10 meters. Clear everybody? So this was about the position and the velocity and their relations. We have two relations. I'm writing it again, that v is equals to dx by dt. This was the first relation. And second relation was delta x, that is equals to integration v dt. This was the second relation. So keep these relations in your mind, and we'll move on to the next thing, which is acceleration. Okay, what is acceleration? Suppose that you have started your bike or your car from zero, like you are starting from the rest, right? So you will just increase your velocity with the help of that accelerator. You just do these things. So you'll start your bike from the zero, and while you'll move forward, you'll just increase the velocity of your car, and it will go up to some certain value, right? So what you are doing, you are changing the velocity with the help of the accelerator, right? So this particular process is called acceleration. It means the rate of change of velocity with which rate. Sometimes you just you just started and you just going slowly, and after some time you just go on the highway and you just accelerate. But what you can do else is that you just start and you just accelerate and you just go like a rocket, right? You just do like this also. So there are plenty of options which we can try in your accelerator, but don't try it at home. So what we are talking about, that how you are rotating the accelerator. It simply means that you can change the speed of rotation by your hand. So the acceleration will be high if you rotate it fast. So acceleration is nothing but the rate of change of velocity. It is nothing but the rate of change of velocity, that how fast or how slow you are changing the velocity. If you'll change the velocity. And one more thing I want to add in this particular thing, that when we were talking about the speed and velocity, you just need to keep in this mind that speed is a scalar quantity, and velocity is a vector quantity. Please keep this in mind. Please keep this in mind that velocity is a vector quantity and speed is a scalar quantity. Yes or no in the chat section. Please write yes or no in the chat section. Then we'll move forward to the acceleration. What we were talking about is this, that you have your accelerator in your hand and you are just rotating that accelerator like and what is acceleration is? This is simply the rate of change of velocity. I'll just simply write this line. It is nothing but the rate of change of velocity. Okay. So, like we studied in the velocity also or speed, that there are two kinds of speeds or velocity. One is the average speed and other is instantaneous speed. Similarly, in acceleration, there are two kinds of acceleration. One is average acceleration and other is instantaneous acceleration. So, there are two kinds of accelerations. One is average acceleration, and other is instantaneous acceleration. Correct. Okay. So average acceleration is what, like we have studied in the speed and velocity. Average acceleration is the total change in velocity upon total time. Total change in velocity upon total time taken, total time taken. And or it can be also written as that delta v divided by delta t. This is the average acceleration. You just take the values of velocity, take the difference of it and divide it by the total time taken. Okay, now the instantaneous acceleration will look like something that you have to minimize the time duration. It means delta t tending to 0. It simply means that it is limit delta t tending to 0, delta v divided by delta t. It simply means that it is dv by dt. Okay boss. So we have two expressions acceleration also, like a average is equals to delta v divided by delta t, and a instantaneous, that is equals to dv divided by dt. Okay. So, one more thing I can derive from a instantaneous, that is equals to, like we did in the velocity also, that just take this dt from here to there and we can write that dv is equals to a dt, and integrate will just have another expression of velocity in terms of time or something like this. So velocity delta v, that is equals to integration a dt. Okay boss. Okay, so we have these three expressions. On this particular topic we can have three kind of questions. One is from this, another is from this, other is from this. Okay, so it can give something like this, that we have velocity, we have velocity as a function of time is 2t cube plus 6t plus some 9, and we have to calculate the instantaneous acceleration at time t is equals to 2 seconds. Okay, at t is equals to 2 seconds, we have to calculate the value of acceleration. So we have to calculate acceleration from velocity. So what is the relation? And notice one thing, that we have to calculate at 2 seconds. At 2 seconds means at that particular instant, and when it is talking about a particular or fixed time, then it is asking about the instantaneous velocity. And what is the formula for instantaneous acceleration? So what is the formula for instantaneous acceleration? That is a instantaneous, that is equals to dv by dt. Substitute the value of velocity in this expression. What we'll get? We'll simply get d by dt into the expression of velocity, that is 2t cube, plus 6t plus 9. Okay, so just differentiate this expression. What we'll get? We'll simply get 6t square plus 6 plus 0. Correct? Okay. Now we have to calculate acceleration at t is equals to 2 seconds. So substitute the value of time, which is 2 seconds, in this particular expression. What we'll get? What we'll simply get that A is equals to 6 into the value of time is 2 seconds. So 2 square plus 6. What will get? 2 2s are 4, 4 is 24, plus 6 is equals to 30, and we know the what is the unit of the acceleration? Unit of acceleration is meters per second square. Why is square? Because velocity divided by time. So one more time term is coming. So this is the meters per second square. Agreed? Agreed? Array, yes or no? Please write yes or no in the chat section. If you have agreed, then please write. Okay. So this is the value of acceleration. Now second category, we can calculate also the average acceleration in this particular 2 seconds. So how we'll calculate the average acceleration? We'll simply suppose that it is saying, say I'll take the same function. I'll take the same function, that's 2t cube, that 2t cube plus 6t plus 9. This was given as the velocity, and you have to now calculate the average velocity, average acceleration in 2 seconds. Average acceleration in 2 seconds. So suppose that it is saying that particle started from the rest at t is equals to 0. So we know that at t is equals to 0, it is given that v is equals to 0. Okay. So if or we can simply, or suppose that we don't, because we have this function, so we'll calculate. It is not saying that it is starting from the rest. Okay. So now it is starting from the t is equals to 0, and we have to calculate the average acceleration in 2 seconds. Agreed? Okay. Now at t is equals to 2 and t is equals to 0, we have to calculate the values of velocity. So what is the velocity? Velocity at t is equals to 0? Substitute the value of t is equals to 0 in this particular expression. We'll simply get that 0 plus 9 means 9, and in this expression it can be written as v1 and v2. So v2 will be put the value of 2. The 2 2s are 4, 2s are 4, 2 2s are 4, 2s are 8, 2s are 16 plus 6 2s are 12 plus 9. It simply means it is 28 plus 9 means 37. Correct? Meters per second. It was 9 meters per second. Now calculate the average acceleration. A average, that is equals to v2 minus delta v by delta t. It was delta v by delta t, means v2 minus v1 divided by t2 minus t1. v2 is what? 37. 37 minus v1 is 9 divided by t2 is what? T2 is what? This could put it as t1 and t2. So 2 minus 0 means 28 divided by 2 means 14 meters per second square. In 2 seconds, what was the value of acceleration? It was 30 meters per second square. But the average acceleration in 2 seconds is simply 14 meters per second square. Agreed? Agreed? Yes or no? Fatafat. Chat section. Okay. The next thing was the expression which was written like v is equals to integration a dt. Suppose that we have given as acceleration a function of time, which is looking like something this: a is equals to 3t plus 5. This is the expression of acceleration in terms of time, and we have to calculate the velocity at suppose that 2 seconds. Calculate velocity at 2 seconds. Velocity at 2 seconds. Velocity at 2 seconds if it is started from rest. If it started from rest. If it is started from the rest. Okay. So we know that the velocity, that is equals to integration of a. What is a? 3t plus 5 and dt. Velocity is what? From at t is equals to 0, velocity was 0. So at t is equals to 0, velocity was 0. And we have to calculate at t is equals to 2 seconds, right? 2 seconds. So just integrate it. 3. What is the integration of t? It is t square by 2. So t square by 2 plus 5, and one integration is t. Substitute the value of t. Or put the limits 0 to 2. It will simply come up to 2 2s are 4 divided by 2 means 2, 2 3 2s are 6, plus 5 2s are 10 means 16 meters per second. 16 meters per second. Simple, simple. Yeah, you can start from here. You just have to realize two things, that what is the expression of velocity? This is simply v is equals to dx by dt. And what is the average of what is the expression of acceleration? That is a is equals to dv by dt. These are the instantaneous velocities and acceleration. If you'll just know these things, I'll simply proceed and you'll understand everything. Don't worry. Okay. Okay, then let's move on to the next thing, which is the constant acceleration. Okay, see, look at the previous expression. Look at the previous expressions. Look at the previous expressions. We had calculated the velocity. Sorry, we had the velocity and we calculated the acceleration. Look at this expression. What is the basic expression? Yeah, this acceleration was coming up to 6t square plus 6. This was the acceleration in this particular expression. Okay, agreed. Other here the expression of acceleration was given. Suppose that if you talk about this particular segment, here the acceleration was 3t plus 5. So as the time changes, so as the time is changing, the value of acceleration is also changing. Okay, so if the value of acceleration is changing, it means it is called as a variable acceleration. Variable acceleration. Okay, suppose that on changing the time or as the time passes, the value of acceleration doesn't change. So we'll simply say that this is a constant acceleration. Constant acceleration means the value of acceleration is not changing over time. Value of acceleration is not changing over time. So constant acceleration means value of acceleration is constant or not changing over time. Correct? Okay, it means a is equals to constant. A is equals to constant. Okay, now assume a case where a particle has started from some velocity. It has some initial velocity. We'll name something like this, and suppose that it has some constant acceleration. Okay, particle is starting with constant acceleration and initial velocity, let us suppose it is u. Let us suppose it is u. Okay, it is u. And since there is a constant acceleration, it means velocity is changing over time. Since the acceleration is constant, but velocity is changed now. So velocity is changing. It means if it is starting from the initial velocity u, the velocity after time t. Suppose that velocity after time t. And what is the value? What is the physical significance of this initial velocity? It simply says that the velocity at time is equals to 0 is u. It is the velocity at time is equals to 0. Means at t is equals to 0. Okay. Now as the time passes, the velocity is changing. Suppose that at time t, the velocity is v. Suppose at time t, the velocity is equals to v. Okay. Now what we are trying to do, we are trying to generate some equations. How it will look like. Okay, just look. A was constant. So what is the expression of A? A is equals to dv by dt, and here this A is constant, right? So A is equals to dv by dt and this A is constant. We can simply write this expression as, dv is equals to a dt. That is the expression we have got. Now just integrate this expression and put the values we have been given. Just integrate this expression. What was the velocity at time t is equals to 0? The velocity was u, and after time t, the velocity was v. Correct? So just integrate this and put the values. You'll get some expression which is going to last long for entire physics. Okay, so this will come up to v, limit from v to u, u to v, that is equals to a is constant, so it will come out to the come out of integration, and t from 0 to t. Okay, so just put the limit, upper limit minus lower limit means v minus u, that is equals to a t. Correct? So it can also be written as v is equals to u plus at, vu plus at, and this is called the first equation of motion. This is called first equation of motion. This is called first equation of motion. First equation of motion. This is called first equation of motion. Clear? Clear? Okay. Now we'll just simply say that there are three kind of equation of motion. Sometimes people say that it is four, but generally there is three. We can derive others from it also. So this is the first equation of motion. Now we'll move on to the second equation of motion. Okay. So we have got v is equals to u plus at. V is equals to u plus at. Now we know that this is the velocity at any time t, but this u is a constant term. Why? Because velocity, if a particle is starting, so it will start from a fixed velocity. Okay, but as the time is changing, the velocity will vary, so we can't say that the velocity is constant or this v is constant. So we'll simply say that at time t we can simply write this velocity at ds by dt, or dx by dt. We'll simply write this velocity as in terms of displacement. So rate of change of displacement, ds by dt, that is equals to u plus at. Now just shift this dt from here to there. It will simply look like ds, that is equals to u plus at into dt into dt into dt into dt. Okay. So now we have to calculate. Now we have some expression in dt and ds. We'll simply integrate this. Just integrate this. What will come up to? It will come like, suppose that we have said that at time t is equals to 0, the velocity was 0, and we have stated that the position is also 0. So at time t is equals to 0, the position is 0, but at time t, suppose the position is s. So what will it look like? It will look something like s is equals to u into the integration of one is t plus half plus a. The integration of t is t squared by 2. So t square by 2. So this is an expression which you have to remember for your entire life, which is s is equals to ut plus half at square. I'll simply write it very clearly that it is half a t square. So this is the second equation of motion. This is what? Second equation of motion. This is what? Second equation of motion. This is what? Second equation of motion. So we have derived two equations till now. First is v is equals to u plus at. Second is s is equals to ut plus half at square. These are the two equations of motion, or we can say these are the two backbones of any kind of motion, any kind of motion, right, which has the constant acceleration. So we'll just write these two equations as v is equals to u plus at, v is equals to u plus at, and second is s is equals to ut plus half at square. Now we have these two equations. Which are in the terms of time. Now we have one more thing, that we will eliminate the time from these two equations, and we'll have some different kind of equation. So just take the value of time from the equation 1. The value of time will be v minus u divided by a, that is equals to time. This is the value of time. Put this the value of time in equation number 2. So it will look something like this, that u is s is equals to u, the value of t is v minus u divided by a plus half a, the value of time is v minus u divided by a whole square. So just square, open. Okay, s is equals to u, multiply it. So vu minus u square divided by a plus 1a, there is a square in the denominator, so 1a will be get cancelled by the 1a, so it will come up to half v square plus u square minus 2vu divided by a. So there is 2 extra in the denominator in this term, so we'll multiply and divide 2 in this particular term. Okay, so okay, just solve it. S is equals to 2vu minus 2u squared plus v squared plus u squared minus 2vu divided by 2a, divided by 2a. What is being cancelled? 2uv get cancelled. Plus and minus get cancelled. Now, what will be left with? We'll be left with s is equals to, there's a v square and 2v square is minus, u square is plus. So there is only one u square divided by 2a. So we'll simply write v square minus u square, that is equals to 2a and is s. So, or we can simply write it also like this, v square is equals to u square plus 2as. This is third equation of motion. This is what? Third equation of motion. This is third equation of motion. This is third equation of motion. Any doubt? Any doubt? Just a second. Just a second. Let me take your doubts. If you are preparing for 2025, if you have not covered like this chapter, then you can study. Otherwise, you can do the PYQs only because you don't have that much time. This is the real suggestion for you, bacha. Okay. Now let's move on to the next page. So we have derived three equations which are looking like v is equals to u plus at. Just memorize these equations. Like, you have to tell every time whenever I ask, tell me bacha, what is the equation of motions, then you have to tell all these equations in this sequence, because these are going to change your life in not in kinematics only, in every segment of the physics. So v is equals to u plus at, second is s is equals to ut plus half at square, and third is v square is equals to u square plus 2as. So these are the three equations you have to remember. Now there is another equation which is being asked, like in the terms of time. What is time? There is no time, but there is said that you have to find the distance traveled in nth time. We have to calculate distance traveled in nth second. Understood? Like, you have traveled a distance from like 0 to something 10 meters. You have traveled 10 meters and it is traveled in 10 seconds. Okay. And now you have been asked that what distance you have traveled in last 10 seconds or any 5th second or 6th second. So you are traveling, like you have to travel from here to here, from point A to point B. The total distance is 10 meters. Total distance is 10 meters and total time taken is 5 seconds. Suppose that 5 seconds. Now suppose that the acceleration is constant. The acceleration is constant. And it is suppose that since the acceleration is constant, the velocity will increase as function of time. Okay. So if we are starting from here, if you are here, okay, if you are here, then in our time t is equals to 0, you're starting from the 0. Okay. In first second, you will suppose that walk from here to here in first second. Okay. In other second, in second means in that second like first second, then second, then third second. Understood what I'm trying to say? First second, this distance is travel, then second, this distance is travel, then in third second, this distance is traveled, then in fourth second, this distance is traveled, and fifth second, this distance is traveled. So you have been asked, what is the distance traveled in nth second? What is the distance traveled in nth second? It means there can be the value of n also, that what is the distance traveled in 5th second, 6th second. Okay. Now how you will calculate this? So if it is saying that you have to calculate the value or the distance traveled in, suppose that in this case, our distance traveled in 4th second. Distance traveled in this particular example, distance traveled in 4th second. Distance traveled in 4th second. So this is the distance traveled in 4 seconds. So how you will calculate this distance? I'll simply show the procedure that just calculate this distance from here to here. Just calculate this distance from here to here and subtract this distance. Understood? Okay, I'll show by the other color that subtract this distance. Subtract this distance from this to this. You will get something like this, because this we have to calculate. Okay, so just calculate the distance. If you have to calculate the distance in distance traveled in 4 seconds, just calculate the total distance traveled till 4 seconds and subtract the distance traveled in first 3 seconds, and you will get your distance traveled in 4th second. Agreed? Agreed? Okay. Now we'll simply go by this procedure to calculate the distance traveled in n second. Chalo. Distance traveled in nth second. 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 I will calculate. Suppose that what we are doing in this particular thing, that we were calculating the distance traveled till 4 seconds and we were subtracting the distance traveled till 3 seconds. So we'll simply do the same procedure in here, in this particular case, that we will calculate the distance traveled till n seconds and we will subtract the distance traveled till n minus 1 seconds. So what is this? It is denoted by Sn, that is equals to, how we'll write it? Distance traveled till n seconds. Distance traveled till n seconds and subtract distance traveled in n minus 1 seconds. Okay. So what is the distance traveled in n second? We'll simply calculate from this formula, second one, that in n seconds, if the initial velocity is u and the acceleration is a, so s1 we'll simply write it like s1, and that is equals to ut. What is the value of t? How many seconds? N seconds. So ut means un plus half a t square. What is the time? N means n square minus distance traveled in n minus 1 seconds means u, what is t? N minus 1 plus half a, what is t? N minus 1 whole square. Agreed? Yes or no? Write in the chat section. Okay, so un plus a n square by 2 minus, just solve this expression. It will come like u, just multiply by minus 1 also, that un minus plus u plus half a n square plus 1 minus 2n. We have just opened this whole square, so it will look something like this. Okay, there is being something cancelled, that un and un got cancelled. What will be left with? Will be simply left with u plus, there is an half a n square and there is also, so just take half a common in these two terms, this and this, just take half a common and we will be left with n square plus 1 minus 2n. So this is the distance traveled in nth second. So just solve it and we will be left with, just write in the other page, that we will be left with Sn is equals to u plus half a and n square 2n square. So 2n square plus 1 minus 2n. So this is the distance traveled in nth second. This is the distance traveled in nth second. Clear? Any doubt? Any? Oh, what? One second, bacha. One second. I have not multiplied the minus sign here. I haven't multiplied the minus sign here, so it will not look like this. I'm sorry. Minus sign. Where is the minus sign? This is the minus sign. So it is a minus. It is minus. I'm sorry. It is minus. So multiply the minus also. I'm sorry. This is minus also. Okay. So what will it look like? It will look like Sn, that is equals to u plus half common and this n square and minus multiply in the internal. Okay. N square and minus n square minus 1 plus 2n. This will be left with n square and square got cancelled. What will be left with? Sn is equals to Sn will be equal to u plus half a to n. You will be left with half a to n minus 1. This is the distance traveled in nth second. This is the distance traveled in nth second. Clear? Yes or no? Fatafat, write in the chat section. Okay. 1 second. 1 second, bacha. Okay, so we have got the expression of this Sn, which is called as the distance traveled in a second. So we have now 4 equations. First 3 were v is equal, write as many as times you can. So v is equals to u plus at. This was the first equation. This was the first equation. Second equation was s is equals to ut plus half at square. Ut plus half at square. Third equation is v square is equals to u square plus 2as, and the fourth equation we have got is Sn is equals to u plus half a to n minus 1. Yes or no? Okay. If you are Hindi audience and you understand Hindi, you can आप सीधा हिंदी वाले चैनल पे आ सकते हो. Don't worry. ठीक है, वहाँ पे अपन 12th के chapters भी कर रहे हैं. Okay, then carry on in the English. Okay, so these 4 equations we have got, and now we'll improvise these equations. We'll play with these equations. Okay, just play with these equations. So now, first of all, let me tell you one thing, that now we'll move on to the motion under gravity and we'll play with these equations. So first of all, we have 2 kinds of motion in the motion under gravity. First, you need to understand that we have 2 kind of motion. One is 1D and second is 2D. This is also called as motion in plane. Motion in plane. And this is also called motion in line. Motion in line. So first of all, for now, we are talking about the motion in line. We are not going into the motion in a plane. Okay, so we'll simply talk about the motion in line. Okay, what is motion under gravity? If we have some object, suppose that we have this object, and this is moving under gravity. Like suppose that I have left it, or take this, or take something better. Take something better. Like we have this adapter, and we have left it from here. Okay, if it is moving something like this or something like this, this comes under motion. This comes in motion under gravity. So this is the motion under gravity. Now we have to calculate how this is moving. What is the time taken by this particular object from going from here to there and there, blah blah blah. And we have also calculate that what is the height measured in this particular section. So there are plenty of questions in this section, and we will try to understand all the possible scenarios in this particular section. Agreed? Yes or no? Write in the chat section. Okay, we'll start from the very basics. This is the first format of this section, that when the body is thrown vertically upward, so the motion of the body will something like this. The motion of the body will something like this, like it is going and it is down. Okay, I'm enjoying this. Okay, now imagine what is being done in this particular scenario, that a particular object is going upward, and after a certain time it is changing the direction of its velocity and it is coming downwards. It is simple 1D motion, and we will break down into the pieces and we'll calculate all these things. Simple. Okay, what is the motion? A particle is going upward with a certain velocity. We have thrown it upwards with a certain velocity, and it goes up to a certain height. Then it comes back. Then it comes back. Simple as it is. Okay, now there are 2 things we have to calculate in this section, that how much time it is taking in this particular motion, that it has gone upwards then coming downwards. What is the total time taken? Now imagine what is the velocity at this particular position. What is the velocity? Since it is changing their direction, then what will be the velocity? What will be the velocity at this particular instance? So at this particular instant, the velocity will be 0. Why? If it has to come downwards, then velocity has to be 0. Otherwise, it can't change its direction. So at this particular instant, the velocity is 0. Suppose that a height h is being traveled. And now we'll just simply apply the first equation of motion, that how much time for the time we have to calculate in going upward. Okay, it is starting with the initial velocity u and the final velocity is v in this section. In the first half we are talking about, so initial velocity is u, so we can simply write v is equals to u plus 80. V is equals to u plus 80. Now we know v, we know u, and we have to calculate the time. What is the acceleration in this particular segment? What is the acceleration? So if a body is moving under gravity, we have to like keep in mind that there is a acceleration which is being downward and whose value is 9.8 meters per second, which is called acceleration under gravity, and we can simply write which is denoted by g, and whose exact value is 9.8 meters per second, and it is also written as approximately 10 meters per second squared. Clear? Hello, how are you? Okay, so this is the value of g, which is always acting downwards. And because of you have to feel the motion, that because of this g, the particle is changing their direction. It is something like this, that you are moving in your car and you are applying the brake. If you are applying the brake, that it means your velocity is being slowed down, and after some time you will be at rest, right? And if there is something, you will be rested. Okay, leave it. So there is when you are applying the brake, it means you are applying a negative acceleration. It means if you are applying the brake, then you are applying the acceleration in negative direction. Yes, definitely comes from the kinematics, and it majorly comes from the motion under gravity. And you can see the question paper 2024 or I'll simply do the PYQs in the next week also, that there are plenty of questions in the JEE main paper, and it comes from the motion under gravity. So I'm just focusing on the motion under gravity, that's why. So just listen to these things, okay? So now where I was saying that if you're applying the brake, it means there is some acceleration which is acting in the reverse direction of your motion. Agreed? So if it is moving upward and a negative acceleration, it means an acceleration is down. It is going upward, acceleration is downward. It is going upward, acceleration is downward. It means its velocity is being slowed down, and at a certain instant it will be at rest. And since the acceleration is continuously working downwards, so after a certain time when it is at rest, it will come towards the acceleration, because there is a force which is acting downwards continuously. Okay, now there are students who always get confused. What is the sign of this g? What kind of sign convention we have to use? I'll simply say that you have to use the sign convention according to me. You'll never get confused. Okay, so always take g as negative. Take g as negative if the particle is going upward. It is natural also. If the particle is going upward, the acceleration due to gravity is acting downwards, so it will simply take you will simply take it negative. And if the particle is coming downward, the acceleration due to gravity is in the same direction. It means you have to take it positive. Just remember this sign convention. Particle is going upward, g is negative. If particle is coming downward, g is positive. Just remember this. You will never get confused. Okay. Now substitute all the values. What is the velocity at the final position? It is 0. That is equals to u. What is a? In going upward, acceleration due to gravity is acceleration, and it is with the negative sign, so minus g, and you have to calculate the time. So what is the time? Time will be simply u is positive and g, u by g. So this is the time taken in going upward. Agreed? Yes or no? So if u by g is the time taken from going from the ground to the upper level, then u by g, just keep in mind, u by g is the time taken from here to here. Okay, now there is second part of the motion also, that particle goes upwards, and then at rest, then it comes downwards. Simple. And the time taken is also same, because it is doing a symmetric motion. It goes from here, then comes from here, and this is the symmetric motion. So if u by g is the time taken from going from position from position 1 to 2, then u by g is the time taken from position 2 to position 3, or we can write in position 1 also. Okay, so this is the time taken from position 1 to 2. Now total time, that is equals to 2 times of this time. It means 2t1, it means 2u by g. So 2u by g is the time taken from this position to this position, and accordingly, I'm sorry, 2u by g is the total time taken in this particular motion. So if a particle is thrown up, now tell me orally, if a particle is thrown upward with 10 meters per second, how much time it will take to come again on the ground? U is 10 meters per second, and substitute the value of g. Now just see, if a particle is thrown upward with the velocity 10 meters per second, what is the time taken? So t is equals to 2. What is the value of u? That is 10. And what is the value of g? It is also 10. So 2 seconds is the time. It means 1 second in going upwards and other second in going downwards. Then that is it. That is it. Agreed? Yes or no? Write in the chat section. So this is the time taken in this particular segment. Now what we were talking about, the time, and we have calculated the time. Now the second aspect is we have to calculate the height. How much height? Like if we have the velocity, like u is equals to 2 meters per second, it will go up to some certain height. If we have, suppose, a decreased the velocity, it will go up to something different height. If we have increased the velocity, it will go up to the mountains, right? So now you have to calculate what height it has covered. Okay, now move on to the height. Okay, what was the motion? Particle is being thrown upward with the velocity u. It is going upwards, then downwards, and height covered is h. What is the velocity at that particular point? V is equals to 0. Apply third equation of motion. Third equation of motion, that was v square is equals to u square plus 2as. What is v? At height h, the velocity is 0, and u is what? U plus 2. What is acceleration due to gravity? If the particle is going upward, acceleration due to gravity is minus g. So minus g. And what is the distance traveled? That is h. Just keep it. Sorry, u square, right? So what is the value of h from here? H is equals to u square divided by 2g. U square divided by 2g. This is the height in terms of u. Hello Raghav, how are you? Okay. If you have to calculate the height, you have to use this particular formula. Yeah, listen one thing. If you know how to use the equations of motion, you will never get stuck in this kind of problems. I never use the formulas directly. I just think that how the particle is being traveled, and we have to calculate all the things like height, time. In the projectile motion, we have to calculate the range also. So if you know the basic mechanics, if you know the basic physics, you have just remembered the basic equation of motion, and you know that where the velocity will be 0, how much height is being traveled, how much the velocity we are giving it, right? So if you know all these things and you know how to apply these things, you will directly solve all these problems without any tension. Okay, done. Okay then we have calculated the height also. Now Now we'll come to the second category. We'll do the problems also. Don't worry. So now second category is free fall. Like previously, what we were doing is we were just giving the velocity in the upward direction and it was coming downward like this. Now we will simply drop it. And now we will calculate some things. That suppose that it is being dropped from height h. There is an object, or there is a ball. Simply there is a ball which is being dropped from height h. Like in the previous case, we calculated two things. First was time, that was 2u by g, and the height was u square by 2g. That were two things we could calculate, and there was nothing else. In this section, we also calculate two things. First is the total time traveled from here to here, if the height is h. Second thing, what is the final velocity of this ball? We calculate these two things. Correct? Now, firstly, we'll simply calculate what is the velocity in this particular position. So if it is dropped, what is the meaning of dropped? If it is dropped, then the initial velocity, we are not giving any velocity, we are just dropping it. What is the meaning of giving velocity? If you are throwing from the downward, like we are throwing, then we are giving the initial velocity. But in the drop, we are not giving any initial velocity. So initial velocity in this particular case will be 0, 0, 0, 0, right? Now, what is the distance traveled? That is h. Now we will calculate from the third equation of motion that what is the final velocity of this ball when it just reaches the ground. Because sometimes bacha says that it has reached to the ground, it is at rest. But believe me one thing, he's not asking what is the velocity when he's staying on the ground. He just asks when it is about to reach the ground, just before reaching the ground, what is the velocity of particle. So you have to calculate. Don't get confused then that when it will come to the ground, it will be at rest. It is not at rest when it is about to reach the ground. It has some certain velocity. Okay, now we'll go up to the third equation of motion, that is v square is equals to u square plus 2as. We have to calculate the value of v, and u is 0 because initial velocity is 0. So v square is equals to 2. What is the value of a? A is acceleration due to gravity, and I have told you that if the particle is coming downward, then always take the acceleration due to gravity as positive g. So g. What is the distance traveled? That is h. So we will come out to be under root 2gh. This is the velocity. Hello Raghav, hello. Okay, अब पढ़ लो, ठीक है. So v is equals to under root 2gs. This is the velocity when it just reaches to the ground. Now we'll calculate what is the time taken in this particular segment. Okay, we can calculate the time by two processes. We have two equations. First is equation number 1, second is equation number 2, in which we can calculate the time. So second equation is bit not confusing, but you can calculate it from first and the second also. You can calculate from any equation. So now we'll calculate the time. So time, we can simply write that v is equals to u plus 80. What is v? V is this, root 2gh. That is equals to u is 0, g is what? Sorry, a is what? G and t. Now we'll calculate t is equals to g is coming in the denominator. 1 root g is cancelled with root g, then it will come up to be root 2h divided by g. So this is the time taken in the free fall. Done. Yes or no? Chat section is only for you. And if you are new on this particular channel, if you are new on this particular stream, just hit the like button and hit on the subscribe button. Put your hand or put your head on the subscribe button. Press on the notification bell also, so that you can get the notifications of the classes. Classes are coming like thrice in a week. First physics, mathematics and chemistry. See the schedule on the channel also. The classes are being scheduled, like tomorrow is your mathematics class and then there is chemistry class. So you can see simply the schedule on the class on the channel. So hit the subscribe button and don't forget to click on the notify, because you have to get the notifications so you can come to the class. Okay, so this is the velocity, this is the time taken. So these are the two formats in 1D motion. Now we will break to the some good examples with which we can just improvise these equations, and we can use these equations. We'll just do these things. Okay. Okay. Now suppose that we'll start from the very basic examples. Like we have a ball which is being thrown vertically upward, vertically upward with velocity 20 meters per second, 20 meters per second, and it reaches to the ground. It reaches to the ground in 4 seconds. In 4 seconds, 4 seconds total time is taken. 4 second total time is being taken. So you have to calculate how much height, but we just leave it. I've given the data wrong. Okay. So if it is traveling with a speed of 20 meters per second, you have to calculate the time because it can't be fixed. Okay. So you have to calculate the time and the height it has traveled. You have to calculate the height and the time. Okay, you can use the directly formulas also, but sometimes generally what I preferred, I never used formulas for these kind of questions because I just know that how to solve these things. I just apply like how I have you have seen the process, that how I have derived these equations. So if you have seen this process, you can simply say that you can apply the equations of motion and you can solve all those things. But if you have remembered the formula, you don't have to take tension. Just put the data in the equations, or you have the formulas, just put the data. You will simply calculate that T is equals to 2u by g. 2u by g means 2 by 10 into 20 means 4 seconds is the time of flight. It is also called the time of flight, 4 seconds, and h is equals to u square by 2g. U square by 2g, it means h is what? 20. 20 square divided by 20. 120 got cancelled. 20 meter is the right answer for this particular question. Yes or no? Yes or no? Yes or no? Done? Done. I don't know. Okay, done. Now I'll give you a simple problem, then I'll take a short break, and you have to calculate, you have to solve this problem in that short break. Okay. The problem is that a girl or the boy is standing on a top of a tower, on a top of a roof also we can say. So it is standing on the top of a tower, and tower is of height 50 meters. Tower is of height 50 meters. It just throws a ball vertically upward with a velocity of 10 meters per second. It just throws a ball with a velocity of 10 meters per second. Then you have to calculate the total time. You have to calculate, it will go something like this, that I have to take something that that if I am doing like this, it will, suppose that I am starting from here, like this is the top of the tower, and I am starting from here. It will go downwards, na? It will simply go downwards. It means it will come up to the ground. It will come up to the ground. So total time taken to reach to the ground, you have to calculate the total time to reach to the ground. Total time to reach to the ground, you have to calculate this time, and I'm giving you a short break. I'm giving a short break, and you have to solve this question in this 5 minutes, 5-6 minutes break, and then I'll again solve it. Okay. Okay guys. Okay, so break is over. Have you solved this particular question? Have you solved? Have you solved this question? Have you ever tried? Chalo, aa jao. What is it is what it is saying? It was saying that what is the total time to reach the ground? There was a particle that was on a particle on the top of a tower, and it is being thrown vertically upward with a velocity of 10 meters per second. We have to calculate the total time from here to here. Okay, now what is the procedure of this particular question? We have two approach in this question, that you can break this motion in two segments. Look, that you have this motion. Now break it into two parts, like firstly like this. First method. The particle is starting from here and it has to reach here, right? So break it like this. First part from here to here, and the second part from here to here. These are the two parts. And calculate the times for these processes, and that will be the total time, right? So first of all, in the first segment, in the first time, what is the total time? How we will calculate? We have the initial velocity, so the time taken from here to here, that will be what? U by G. We have calculated this thing. So T1 will be equal to U by G. U is what? 10 meters per second divided by, what is G? G is also 10. So time is what? 1 second. Now come to the second part. The second part, what is it is doing? It is starting from the rest and it is coming downward. It is being dropped. But what is the height? From which it is being dropped? So just calculate first of all this height. So H is what? U square by 2G, and U is what? 10. So 10 square by 20. It means it is 5 meters. So what it was initially? It was initially 50 meters. Now 5 meters extra. So this is 5 meters. The total height is 55 meters. Now we have to calculate this time. So this time will be equal to T is equals to root 2 H by G. This was the formula. So root 2 H is what? 55 divided by G is what? 10. 55 2s are 110 and 0 got cancelled. Root 11 seconds. Root 11 means around 3 point something seconds. So 3 seconds this and 1 second this, around root plus total time is 1 plus root 11 seconds. This is the total time taken. So this was the first method with which we can solve this particular kind of questions, right? Yes or no? Chat section is only for you. Okay. Now come to the second method. How we can break down this particular motion to other part, that we were starting from here and we had to reach till the ground, and break this motion like this. Firstly, it will go and come up to the same level, like this, from here to here, and again now from here, what was the velocity? It was 10 meters per second. And and when a particle is thrown vertically upward and when it comes down to the same level, it has the same velocity but in the opposite direction, because we had given this particle the velocity at 10 meters per second in the vertically upward direction, but now it is coming downwards, so the velocity will be velocity will also be the 10 meters per second. So here the velocity is 10 meters per second. Now this segment plus this segment from here to here, this segment is T1 and this segment is T2. So now T1 is what? T1 is what? Total time is 2u by g. 2u by g means 2 seconds. 2 seconds. And in this section the particle is thrown like this with the velocity 10 meters per second. It means we have to calculate, but this is a bit complicated method, because here we have to calculate the time with using the two equations. Like first we have to calculate what is this height was 50 meters, right? So firstly we have to calculate what is the velocity at the particular instant. Then or we can simply say first of all calculate the velocity. So what is the velocity? V square is equals to u square. U square is what? 10 meters, so square is 100 plus 2gh. 2g is 10 and height is 50. 52s are 100 and this is 1100. So v is what? V square is what? This. So v is what? V is equals to 10 root 11. 10 root 11. This is velocity. Now we have to calculate the acceleration. Now we have to calculate the time. Now we have to calculate the time. So v is equals to u plus 80. V is what? 10 root 11. 10 root 11. U is what? 10. So minus 10, that is equals to 80. A is what? 10 into time we have to calculate. 10 got cancelled. T2 is what? Root 11 minus 1. This is T2. So what is the total time? Total time is T1 plus T2 means 2 plus T2 is what? Root 11 minus 1 means root 11 plus 1 seconds. This is the same answer which we were getting in the first method also, root 11 plus 1 seconds by this method. And root 11 plus 1 by this method also. So this is how we calculate the time if a particle is thrown vertically upward from the top of a tower. Clear? Yes or no? Done? Now move on to the next thing. Now how will one more example we can take. That suppose that your friend is standing on the window of his home, right? Your friend is standing on the window of his home and he is standing on the height of 100 meters, and you have to give a pen or something, a ball, to your friend. You are standing here. Okay, now the question is what is the velocity you will give to the ball so that it can reach the hand of your friend? What is the minimum velocity? So you are throwing a ball vertically upwards with some velocity v. What is the u minimum? Find u minimum so that your friend catches the ball. What is the u minimum? So how you will calculate u minimum? So we'll simply say that what is the u minimum? U minimum is simply when it reaches till to the hand of your friend. It means by reaching to the hand, the velocity in the hand will be 0. Finally, the velocity at the final position will be 0. So here v is equals to 0. Okay, you have to calculate the u. And what is the distance? This is 100 meters. So just apply the third equation of motion. V square is equals to u square plus 2as. What is v? 0. That is equals to u square is what? We have to calculate u square plus 2. What is a? Acceleration is downward, the ball is going upward. So minus g. So minus g. S is what? 100 meters. Just put the values. What it will give? U square, that is equals to, this is 10 means 2,000. It means U is equals to root 2,000. It means we can also write it like 4 will also come out. So 200 to what, 20 root 5 to the 4, yeah, 20 root 5 meters per second. This is the required velocity with which your friend can catch the ball. Clear? Done. So this is the U minimum. Now we'll move to the next segment, which is called graphs. Graph is one of the most important things in this particular section in kinematics, because like you can use graphs as a tool. Means if you know the graphs, you can solve some typical problems from it, and they will be easier than the normal method. So graphs are that like easy. So first of all, we'll understand that how you can understand the graph. What is the physical significance of a particular graph? It is if it is being given, like if you have been given a velocity time graph, or a displacement time graph, or an acceleration time graph, what you can extract the data from that particular graph. Okay, now okay, so first of all, we'll use four kind of graphs here. First of all, suppose that this kind of graph is given, y, x, and this kind of graph is given. What is signifies that y is equals to constant. Y is equals to so you just need that, you have to read these graphs. Y is equals to constant. Suppose that we'll talk about the straight line. What is the graph of straight line? What is the graph of straight line? Y, x. So this is a simple graph of straight line, and its equation is y is equals to mx plus c. You just need to keep these things in your head, that this is the constant motion, not motion, this is the constant line. This is a equation of a straight line whose slope is m and the intercept is c. So this is the intercept c. Now third thing, parabola. There are three kind of graphs only. So first is constant, second is straight line, third is parabola. This is what straight line, straight line. Third is parabola. So there are four kind of parabolas. But first of all, y square is equals to plus minus 4ax. This is two parabolas. First is y square is equals to plus ka 4ax. Second is y square is equals to minus 4ax. So these are two parabolas. Second is x square is equals to minus 4ay plus minus 4ay. These are other two parabolas. So these are total four parabolas. I'll just plot it simply, that if you have been given y square is equals to plus 4ax, it will simply look something like this. It will look something like this, yx. If you have been given y square is equals to minus 4ax, it will look something like this, yx, and the opposite side. Other x square is equals to plus 4ay. So it will look something like bowl, x, y, right? Something like this. If you have been given x square is equals to minus 4ay, it will look something like this. This is y, this is x, and parabola will look something like this. So you just have to keep these things in your mind, and we'll proceed, and we will firstly look that how you will read a graph. First of all, we'll understand the reading of a graph, that you have been given a velocity time curve, or displacement time curve, or acceleration time curve, how you will extract the data from those particular graphs. So reading of graphs. So first of all, we'll talk about xt graph. What is it? Displacement time graph. So if you have been given a graph like this, suppose that a graph is being given like this, I'll draw something like this. This is displacement, this is time, and displacement is like this. So what it is saying, that You have to understand this, you have to read this, that if a graph is constant over time, if xt graph is constant over time, that it is simply saying that particle is at rest, because the position is fixed. Suppose it is x naught, so x naught is fixed, it is not changing over time. So we can simply say particle is at rest. Particle is at rest. Secondly, if a graph is being given like this, x, this is t, and graph is something like this, so what it is saying, that its position is changing. Certainly you are seeing that with time is changing, the position is also changing, but we have to keep one thing in mind, that the position where the particle is being started, that is origin. It means the particle is starting from the origin, and since this equation is a straight line, it simply means it is moving with constant velocity. It is moving with constant velocity. So starting from rest, or we can say origin, say starting from origin and moving with constant velocity, you have to write these things in your notebook. Moving with constant velocity. Clear? Yes or no? Clear? So this is what this graph is saying. If a graph is a straight line, we can simply say that the velocity is constant. And also we can say, if the velocity is constant, the acceleration is zero. Okay, this is how you will read this particular graph. Now moving to the next graph of xt. Suppose that this is x, this is t, and a particle is moving something like this. This is also a straight line, but it's not starting from the origin. It simply means the particle is not starting from the origin. It is starting from x naught. Suppose this is x naught, and we will simply say after starting from the x naught, the particle is moving the constant velocity. It is not starting from the origin, but it's still moving with the constant velocity. So starting from x naught, starting from x naught, moving with constant velocity. Starting from x naught, moving with constant velocity. Okay, let's move on to the next graph. Suppose that a graph is being given like this, xt, and a graph is given like this. A graph is given like this. Is not straight line, this is parabola. And if it is parabola, it simply means that the velocity is not constant now. The velocity is also changing. It means there is some acceleration which is increasing the value of velocity. Why I'm saying so? Because you know one thing. Because we know one thing, that v is what? dx by dt. And if x was constant, so if x was constant, we'll simply say that velocity was zero in the first case. Now if we are saying the velocity is constant, now see, if the velocity is constant, we'll simply write dx is equals to v dt. Integrate this relation. If v is constant, it will come out of the integration. V is integration dt, and it is x. We'll simply write x is equals to vt or plus some constant. So look, this is the equation of straight line. And one more thing, the acceleration is constant in this particular case because the velocity is constant. But suppose that velocity is proportional to time, meaning velocity is changing with respect to time. Now if we'll simply say v is equals to kt, now we have to find the displacement. So we'll simply write dx by dt. V as dx by dt is equals to kt. So dx is equals to kt dt integrated with respect to time. What it will come out to be? X is equals to kt square by 2 plus constant. So there is a square term, and if there is a square term, it simply means the displacement is increasing with respect to time, and velocity is also increasing because this is a function of time. So if it is now differentiate velocity. if you will differentiate this, you will get a is equals to k. It means acceleration is constant. It means acceleration is constant. Done? Yes or no? Write in the chat section, yes or no. Done? Okay, so these are the graphs of x versus time or displacement versus time. If you have been given the velocity time curve or acceleration time curve, what you will get, suppose that you have been given velocity time curve, velocity time curve. So if you a velocity time curve is given like this is velocity, this is time. So if a velocity curve time is given like this, is given like this is the velocity time curve. It means as the time is proceeding, the velocity, here it is what? Velocity is 0. It means the particle is not moving, particle is at rest. If you have to show the particle at rest in the velocity time curve, it simply means you have to show a straight line which is on the time axis, Clear? Done? Yes or no? Okay. Now this shows the particle is at rest. Now move on to the next graph. This is velocity, this is time. Now the graph is something like this. The graph is something like this. It simply means that it has some certain velocity and it is moving with a constant velocity. It is moving with a constant velocity and it is just simply write constant velocity. Constant velocity. Constant velocity. Simple. Now suppose that velocity time curve is something like parabola or something else, so we'll simply say that the velocity is not constant. Done? There are some things also. Acceleration time curve, AT curve. Okay, so if a AT curve is given like this is A, this is time, and from here the curve is like this. The curve is like this is the curve. So we can simply say the acceleration is 0, and the acceleration is 0, then the velocity is, the particle is moving with the constant velocity. The particle is moving with constant velocity. Particle is moving with constant velocity. Correct? Done? Yes or no? Now these are the things. Now if I say that the AT curve is something like this, it means acceleration is constant, and if acceleration is constant, it means the velocity is increasing. Velocity is increasing with respect to time. Now we'll do some problems that first of all we have something, and we'll say, or we'll just give some statements on the basis of those expressions. I'll firstly write those expressions that we had. V is equals to dx by dt. We had one expression as A is equals to dv by dt. Right? Now can we write on this part with this equation that dx or x is equals to integration of v dt, and with this expression we can write v is equals to integration a dt. Correct? Yes or no? Now what dx by dt physically shows that if there is a xt curve, this is x, this is t, and if there is a xt curve and we have something like this xt curve, and we just find the value of slope, at any particular point, we just calculate the value of slope at any particular point, then this slope will give the velocity, because dx by dt shows the slope of xt curve and it physically signifies the velocity. Agreed? It means slope of xt curve will give velocity. Now Now, come to the next thing. Is there anything giving suppose that we'll talk about this thing. If we have VT curve, and we just find a slope on any particular point, so slope of VT curve will give acceleration, agreed. Now these are the physical significance of these two expressions, that if you draw the xt curve and you find the slope at any particular point, you simply find the velocity of that curve. Secondly, if you draw the vt curve and you find the velocity, you just find the slope at any particular point, you will get to know that what is the acceleration at that particular instant. Now move on to the next things. These integration also signifies something, that if we have the VT curve, and integration have a physical significance, very beautiful physical significance. I'll show you, I'll let you know that if we have a curve, yx curve, I'll simply explain you. If we have a yx curve, and suppose that this is a curve, and now we have to calculate the area falling under this curve. The area falling under this curve means this area I'm talking about. So how we will calculate this particular area? There is a catch. How we will calculate? This is not a regular figure like rectangle which we can length into breadth, but we can break this figure into some pieces, and we'll calculate the area of those particular pieces, and we'll just merge all the area. Agreed? Now how we'll cut this? Just go to the x and take an element of dx. Just go to x and take the element of dx. This is element of dx, and this is a function of x. This is the function of y as a function of x. So this will be something y. So if we just take this part out, it will look something like this. And this particular portion is not variable. Why I'm saying not variable? Because this is looking like a rectangle. Exactly. So if we have to calculate the area of this particular section, we'll simply write dx into y. So y into dx is the area of this strip. This strip has the area of y dx. Now if we have to calculate the total area under this curve, then what we'll do? We'll just integrate this thing. So this will be the total area. This will give us the total area. That's what we are doing here. If we have VT curve, now I'll write these expressions, that x is equals to integration v dt, and v is equals to integration a dt. So if we have VT curve, and we just calculate the area under curve, so this area will give us the displacement and distance. How? I'll show you. Displacement and distance. Similarly, if we have AT curve, and we have some area under curve, so this area under curve will give us the velocity. Here in this section, xt curve, the slope of xt curve was giving velocity, and slope of vt curve was giving acceleration. Here there is xt curve and vt curve, but in this section there is at curve, and there is vt curve. But in all those two pages, vt curve is constant. So if we have VT curve, we can extract all the data about that particular particle, because the slope of VT curve gives the acceleration, and the area under VT curve give the displacement or distance. So if the most useful graph is VT curve, because if we have VT curve, we can calculate all the data, all the things from that particular curve. Agreed? Yes or no? Write in the chat section. If you have any doubt, you can write in the chat section. Chat section is only for you. Correct? Let's move on to the next thing. Now we'll plot some graph, but first of all, before this, I'll show you something. I'll just explain 1-2 things on the behalf of those things. You will be able to solve all the questions of this particular section. So first of all, if I show that there is a xt curve, which is something like this, what it physically signifies, that the position of a particle initially increases, then it decreasing over time. It simply means the particle is returning to its own position. Correct? If we have VT curve, this is the most important curve, VT curve. What is the VT curve? VT curve, the slope of VT curve was giving acceleration, and the area under VT curve was giving displacement distance. Suppose that there is a curve something like this. This is a VT curve. Now we have to calculate the displacement. I showed you that the displacement, the area under VT curve, what was? Area under VT curve was giving the displacement or distance. So how a thing can give the displacement and distance simultaneously? It gives. And the JEE Main has collected this problem many times. There are a lot of problems like this in JEE Main. Okay, so we have to calculate the displacement first of all. So for calculating the displacement, what we have to do, there are 3 segments, there are 3 sections. Suppose that this section has area A1, this section has area A2, and this section has area A3. We have to also consider the sign, because the upper area is positive and the lower area is negative. So this is the plus A1, this is the minus A2, this is the plus A3. So if we have to calculate the displacement, then we don't have to remove the sign. We have to take the areas and add all the areas with their sign, means A1 plus A2 plus A3 as it is. Put the value of A2 plus put the value of A3. But if we have to calculate the distance, then how you will calculate? You will just take the mod of all these areas and add them. You will just take mod of all these areas, means mod A1 plus mod A2 plus mod A3. So this is the total area. So this is the total area, and this gives us the total distance traveled in this particular section. Now we will move on to the problem. There is a problem which is what is saying. It is saying if a body is projected vertically upwards with velocity u, take the projection point to be the origin and the upward direction as positive. We have to plot all the 3 graphs. Either it is xt curve, or it is VT curve, or it is AT curve, right? So we have to just calculate. We have to just first of all understand the scenario. What is going? Body is projected vertically upward with initial velocity u. Arthat, it means it goes like this and comes here. Simple. Okay. Now first of all, we will plot xt curve. Okay. Since there is a constant acceleration which is being downward continuously, so the path will not be like, we'll say the equation of the displacement or distance will be a parabola. Simple. So it will go something like this. Or we first of all we can write the equation also, so that we can easily show it on the graph. Okay. So what we can write is x is equals to initial velocity is u, ut minus half gt square. This is the equation of x, or y we can simply say. This is the y, right? So see, I'll simply write y, because it just confuses with x and y axis. So this is y, this is y. Correct? Y is equals to ut minus half gt square. So this is a parabola having a negative sign in t square. And negative sign in t square means y is equals to something minus x square type graph. It means the particle's graph is something like this. something like this, negative type parabola. When it reaches to the extreme position, it reaches to the height h, then the equation of motion changes. The equation, how the equation of motion changes, now the g is positive. Now the g is positive, and there are two things. If we are writing the y includes two things. First is displacement and second is distance. If you are talking about the displacement, so displacement is what? It just goes something like this. This is the time u by g, and then it comes back to the original position. Then it comes back to the original position. This is the displacement. This is the displacement. This is the displacement. But if we talk about distance, distance is not, if it is moving, so distance is always increasing. So just how you can plot this is catch also, that you can take the mirror image of this thing. So if you just take the mirror image of this thing, this will give us the distance. This will give us the distance. So this is the xt curve you will plot. Simple. Okay, let's talk about this. Okay, so y is equals to yeah, this was the y versus t curve. And now what we'll do, we'll simply plot the velocity time curve. We'll simply plot the velocity time curve. This is v, this is t. Since we have given a positive velocity, and there is a negative acceleration, so velocity will decrease. And since the acceleration is constant, it means the velocity will be a straight line curve starting from the u. Suppose that this is at a particular point u. Now velocity will decrease as the time passes, and after time t is equals to u by g, the velocity becomes 0. The velocity becomes 0. This is what? This is time u by g. Now then it again comes to the negative axis. Then the velocity becomes negative, and it again increases. It again increases. So it will go something like this. So this is the vt curve. This is what? Vt curve. Understood? Done. Now we'll plot the at curve. This is the easiest curve in this particular example. So how we'll plot the at curve? At curve. So acceleration is positive or negative? Acceleration is positive or negative? Or acceleration is changing the direction or not? So acceleration is always or continuously showing the negative or the downward direction. So acceleration is always negative, and it is showing the negative g. So this is the graph of acceleration. So these are all three graphs of xt, vt and at which we had to plot. Done? Yes or no? Write in the chat section. Now we'll move on to the next problem. Next problem is what? If a body is dropped from a height h above the ground t, take dropping point to the origin and upward direction as positive. We have to find, sorry, it just slips and just shows its own nature, right? So we have to, what it is doing, that ball is dropped from height h, and we have to take the dropping point at origin. This is 0, 0. Now we have to find all three graphs. First is xt, second is vt, third is at. We have to calculate all these graphs, right? So first of all, xt curve. Let it be small. This is what? X versus t. So what it is doing, it is just coming downwards. It is coming downwards only. Okay. Now. What is the position? What is happening with the position? Since the upward direction is positive and it is coming downward with a negative acceleration, so it is just showing that it is like going in the negative x-axis or negative y-axis, whatever you can say, right? So it will simply start from origin. It will simply start from the origin, and it will go downwards. It will go downwards like this. It will go downwards like this as the time passes. Then, so this is the xt curve. Now we'll plot the vt curve. Since we have started since we have started from the rest, and the velocity is increasing but in negative direction, it means the graph will look something like this, straight line but increasing. Now acceleration graph cannot be changed because acceleration is always acting, or we can say acceleration due to gravity is always acting in the negative or negative direction, right? Done? Yes or no? Any doubt till here? Any doubt till here? One second, guys. Okay, now, yeah, let's move on to the next problem. What it is saying? It is saying that the particle starts from x is equals to 0 and initial speed 10 meters per second and moves with a constant speed 10 meters per second for 20 seconds, and then retarding uniformly comes to rest in next 10 seconds. Means particle starting from the rest origin, okay, initial speed 10 meters per second, moves with a constant speed for constantly 10 meters per second for 20 seconds. It means for first 20 seconds the velocity is constant and the acceleration is 0, and then retarding uniformly comes to rest in 10 seconds. Okay, first of all we will plot xt curve. What it is doing, that initially the particle is at 0 and it is moving with the constant velocity of 10 meters per second for 20 seconds. So for 20 seconds it just moves with a constant velocity, means distance is increasing. Now it is retarding uniformly and comes to rest. If it is coming to rest, it means how you can show this, you can simply say that suppose that it is starting from here, right? It is starting from here and it is moving with 10 meters per second. From here to here it just moves with a constant velocity, and now it starts like retarding. So the velocity will decrease and it just comes to rest. Means now the parabola will start. And after some time t, in next 10 seconds, means this is 30 seconds, it will come to rest. This is parabola and this is straight line. Okay, just don't get confused. This is what it is doing. This is the xt curve. Now we can show the vt curve also. Vt. So it starts from the 10 meters per second. It moves till 20 seconds with the same speed. So 20 seconds, it just moves with a constant velocity, and now it starts retarding. So now it comes to the rest means velocity is 0. So it will come like this, velocity is 0. So this is the vt curve. Now at curve. So what is an at curve? In at curve, firstly it will have 0 acceleration till 20 seconds. Then for next 10 seconds acceleration is negative. So for here it is 0, and then in next seconds it is negative. Done guys? Yes or no? Any doubt? Just a second. Now we'll move on to the next thing. Okay, what is next is motion in a plane. Means we have started that 2D motion, or motion in a plane means if a particle, like suppose that we'll say the particle is moving in x-axis as well as y-axis, we'll simply say that this is the motion in plane. Just a second. Okay, so first thing which we will discuss in this thing, that is projectile motion. what is projectile motion, what is projectile motion, what is projectile motion. So simply we'll say that this is y, this is x, and the particle is thrown from here. A particle is thrown from here with velocity u and angle theta. So now we'll understand what is circular motion, sorry, what is projectile motion. So to analyze this projectile motion, we'll break this initial velocity u into two components. First is along the x-axis and second is perpendicular to the x-axis, meaning in y-axis. So we'll break this. First is ux in x direction and then uy in y direction. So this is along theta, this ux component is along theta, so it will be u cos theta and this will be u sin theta, correct? So there are two components of velocity. First thing we have to analyze that if we are doing a projectile motion like this, if we are doing the projectile motion like this, so there is an acceleration continuously acting in the downward direction. That's why the particle is doing like this. We had studied like this in 1D, but it is 2D. It is 2D. It is 2D. Like it is going like this. Okay. So we have broken this velocity into two components. First is parallel to x-axis, and other is perpendicular to x-axis. Now, in which direction the acceleration is working? So acceleration is always downwards. So this is the acceleration. This is the acceleration, and a particle will go something like this. Particle will go something like this. So first of all, you have to understand one thing, that there is no change in ux. There is no change in u cos theta. It means it is constant over the motion. It is constant over the motion. But u sin theta is changing, because imagine we have studied that if a particle is projected vertically upward and it has some retardation in downward direction, so it just loses its energy or kinetic energy, and it just goes to the rest at the top, and then it again increases the velocity and comes to the bottom, right? So this component is acting like motion in 1D, vertically upward, vertically downward type thing. Okay, now we have broken this particular thing into two motion. So we generally calculate three things in this particular type of questions, in particular type of projectile motions. That first of all, we calculate time period. Secondly, we calculate what is the height, total height. What is the height? And third is range. Range means this thing. What is the distance traveled, total distance? And height is this. This is height. Right? So first of all, we'll calculate the time of flight. How we'll calculate time of flight? We'll just simply say, if a particle is projected vertically upward, then initial velocity in the vertical direction is u sin theta. So u initial uy is equals to u sin theta. And final velocity in vertical direction is what? Final velocity in vertical direction is what? 0. So vy is 0. And acceleration is negative of g. So what is the time taken? Time is equal, or we can apply the first equation of motion. V is equals to u plus at. V is what? 0. That is equals to u. U is what? U sin theta. A is what? Minus g into t. So t is what? U sin theta by g. U sin theta by g. So this is the time taken from bottom to the most upper point, right? This is the total time taken in this section. Now this is the time till here. Now it will come downwards. When it is coming downward, it will take the same time because it is a symmetric system, right? So if u sin theta by g is the time taken in going upwards, then u sin theta by g will be the time when it comes to the downward, right? So the total time taken is t is equals to 2t. That means 2u sin theta divided by g. Done? Yes or no? Any doubt? Okay. 2u sin theta is by g is the total time taken. Now this was the figure. This was u cos theta, and this was u sin theta. Now total time is what? 2u sin theta by g. Total time is what? 2u sin theta by g. Now you have to understand one thing, that there is no acceleration in horizontal direction. Is there any acceleration in horizontal direction? No. So since there is no acceleration in the horizontal direction, it means the velocity is constant over the time. Means if we have traveled the distance r, so for distance r, velocity is constant, and if velocity is constant, there is no equation of motion. We will just simply write the velocity is equals to distance upon time. Speed is equals to distance upon time. What is the distance? U cos theta. Sorry, what is the speed? U cos theta. What is the distance travel? That is r divided by what is the time? T. So r is equals to what? U cos theta into the time period. So u cos theta into what is the time period? Time period is what? 2u sin theta divided by g. So it will come like u square. 2 sin theta into cos theta is the formula of sin 2 theta. So u square sin 2 theta by g. So this is the range. This is the range. Done. So this is the formula for range. Now we have to calculate the height. As we calculated in the motion in 1D also, we calculated the height. So in the same procedure, we'll calculate the height. Okay. So how we'll calculate? This is the height. This is the height, right? So how we'll calculate? H is the same second equation of motion. That was ut minus half gt square. So H is equals to ut minus half gt square was the equation. What is u? Initial velocity in upward direction, u sin theta into what is the total time taken? What is the total time taken from here? This time taken is u sin, total time is 2u sin theta by g. So this time will be u sin theta by g in going upward. So u sin theta by g minus half g t square means u square sin square theta divided by g square. G got cancelled. What will be left with? U square sin square theta by g minus u square sin square theta by 2g. So just subtract these things. What will be left with? U square sin square theta divided by 2g. This is the value of h. This is the height. U square sin square theta by 2g. So we have got three formulas. First is of time of flight. T is equals to 2u sin theta by g. T is equals to 2u sin theta by g. Second is range, that is equals to u square sin 2 theta by g. And third is h is equals to u square sin square theta by 2g. U square sin square theta by 2g. Correct? Done? Yes or no? Chart section is only for you, right? Okay. So what we'll do now, we'll just simply solve the equation of motion for the projectile. We'll just calculate the equation of motion for the projectile. So what is the equation? Suppose that, how we'll calculate? Suppose that the particle is moving something like this. So at a time t, suppose that the position of particle is x comma y. Okay, so we can simply write that y is equals to, y is the what? Height. Y is what? Height. And y is equals to u is what? U sin theta, right? So u sin theta into t minus half g into t square. Now how you will calculate the time t? So this distance is y, so this distance is x, and the time which it is taking to go to the y, the same time is taken by the x also. So x is equals to what? What is the velocity in the horizontal direction? That is u cos theta into u sin, yes, correct, u cos theta into time. So time is what? X divided by u cos theta. Just put this thing here. So we will be left with y is equals to u sin theta into x divided by u cos theta minus half g. What is t square? So x square divided by u square cos square theta. And this is important. This is important because sometimes it just shows you an equation of motion of projectile and it just says that you have to calculate the value of theta, you have to calculate the value of initial velocity, you just calculate all those things from the equation of motion. So you just have to remember this thing. Okay, so y is equals to something or dot cancelled, u got cancelled, sine by cos is equals to tan. So y is equals to x tan theta minus gx square divided by 2u square cos square theta. So this is the equation of projectile. Done till here? Done? Yes or no? Okay then. I'll move on to the next thing. Now, suppose that there are some small questions also on this, like if I'm saying that if a particle is projected with 30 degree and with velocity 60 meters per second, find all the things. So you have to calculate the time of flight, which is 2u sine theta by g. You can calculate all those things. I don't need to write these things because you just have to put the data in these particular equations or particular formulas, right? But there is some things you have to understand, you have to analyze. That suppose that you have been given that range is what? Range is equals to u square sine 2 theta by g. This was the equation, or this is a formula for range. Okay, now you have been asked that what should be the value of theta, what should be the value of theta for which the range is maximum. What should be the value of theta for which the range is maximum? So if you have to maximize the range, it means you have to maximize the sine 2 theta. You have to maximize the sine 2 theta. Now for maximum range, sine 2 theta is equals to 1, because that is the maximum value of theta, sine theta na. So this is the sine 2 theta is equals to 1. It means it is sine 90 or sine pi by 2, sine 90, definitely right, sine 90. So 2 theta is equals to 90 degree, means theta is equals to 45 degree. If someone asks what is the range, when will be the range maximum, so you'll just simply say range will be maximum if theta is equals to 45 degrees. So for theta is equals to 45 degree, the range will be maximum. There is one more thing, that if I suppose that I say that put 90 minus theta, instead of theta, just put 90 minus theta. So r will be what? U square sine 290 minus theta divided by g, multiply 2 inside. So r will be equal to u square sine 180 minus 2 theta, and we simply know that sine 180 minus theta is sine theta. So it will simply look like u square sine 2 theta by g. So it is same as this. It is same expression, u square sine 2 theta by g. So we can say if we take theta or 90 minus theta, range will be same for both cases. So suppose that if I say theta is equals to 30 degree, so range is something 20 meters. So what should be the other angle for the same range, or 30, jo bhi 20 meters I have taken. So for the same range, there are two angles for which the range is same. So there are two angles. For which range is same, and that is one is theta and other is 90 minus theta. Or we can write this is theta 1 and this is theta 2. So we can also write theta 1 plus theta 2 is equals to 90 degree. Done till here? Yeah, simply we can say that ry is equals to uy by g, because there is a velocity which is responsible. No, wait a second, wait a second. You are saying r is equals to uy by g. Why uy by g? R is not uy by g. T is uy by g. T or half time is equals to uy by g. Uy by g. R is not. R is not. Okay. Done till here. So there are two kind of angles for which the range is same. Okay, let's move on to the next thing. Okay, before moving on to the next thing, we'll just take a short break of 5 minutes. 5 minutes break. 5 minutes break. Before moving on to the next things, just take a 5 minute break. Just take some water and just clear your throat. Anji bhai, I'm back. Yeah, we will definitely take on that. I have also already announced on the channel that what we are planning on this, that I'm taking 2 sessions on a particular chapter. Like in one session, I'm just doing the theory part. I'm just taking the theory that this is the things, this is the projectile motion, this is the 1D motion. All those things I'll cover in one lecture. And in other lecture, what I will do is I will take all the PYQs, like in the next session next week, same Wednesday. I will take all the PYQs of kinematics from 2002 to 2024 that will work for 2025 students. That I'm already doing in Hindi, but here I am doing in English. Okay. So, and if you are a Hindi student, what's your name? I can't pronounce properly. So if you are a Hindi student, then you can take the benefit of those classes. Okay, if you understand Hindi, I'm taking all the PYQs in Hindi. Kinematics is done. Laws of motion, no. Electrostatics is done. Current electricity is done. So all these chapters I've already did on the Hindi channel, JEE Finity. Okay, but here I am doing on the English. So there are 2 classes. One is for 2026 dedicated, and second is for both 2026 plus 2025. So you can take the benefit of those classes. Okay. Let's move on to the next thing, that is relative motion. Okay, but before relative motion, I had to tell you one thing, that if a projectile, one thing I forgot to tell, that if a projectile, if a particle is thrown not like this, it is thrown like horizontal, it is being given a horizontal velocity from a height h. This is one of the major problems. Are you talking about this channel or Hindi? On this channel, we'll do the kinematics PYQ session next week, in which we will cover all the PYQs of kinematics from 2002 to 2024. All the PYQs. Don't worry, bacha. And if you are talking about the Hindi, then it is already available, and we are doing all those things there. Okay. So this is the U, velocity U, and height h. It is thrown with velocity u. Now there are 2 things we have to calculate. First is what is the time taken by this particle to come to this is ground. This will come like this. This will come something like this. So what is the time taken? Okay, I'll definitely cover, don't worry. Okay, so if it is thrown like this, we had to calculate 2 things. First is the time period or time of flight, whatever it is. So firstly, we need to calculate the time, and secondly, we cover that what we calculate what is the range. So first of all, we'll proceed with the time. Okay, so just think about it, that we have not given any kind of velocity in horizontal direction. Agreed? But there is a acceleration in a vertical direction, or this direction. There is, because of that particular acceleration, the particle is going downward. Otherwise, it could go like this, right? So the initial velocity in we're calculating in the vertical direction. Vertical. Okay. So in vertical direction, the initial velocity is 0. Uy is 0. But the displacement is h. So we will simply calculate what is the time taken. How you will calculate? We'll simply apply the second equation of motion, and that is equals to s is equals to ut plus half it square. So initial velocity is 0. So h is equals to ut term will get 0, and we will be left with half gt square. So time will be simply 2h by g, and then a under root. So this is the total time. So we can write it as a capital T also. So this is the total time taken by this particle to come to the rest. Done. Okay, no problem. Okay, then now we have to calculate the range. What is the range? R is equals to what? How we will calculate? We will simply do one thing, that we have the time in which it has traveled this much distance. Now what is the value of r, we'll calculate from this time also, because because there is no acceleration in horizontal direction, bacha. So we'll simply write r is equals to velocity into time. There is no need of acceleration. So what is the velocity in horizontal direction? U. But the time taken will be same now. So what is the time taken? Under root 2 h by g. So this is the time taken in horizontal direction. This is the time taken in horizontal direction. Done. Okay, this is the one of a type which is very important, and it is being frequently asked in your JEE Main examination. So you need to understand these things, that there are three kind of varieties. All varieties I have told you till now. That first is motion in 1D. Motion in 1D, particle will simply go vertically upward, then it comes downward. Second, in this variety, the free fall, right? Free fall. Third is basic projectile, that is already explained. Last is this kind of thing, that a particle is thrown horizontally on a height h, right? One more thing that is not that much useful in JEE Main, but it can be useful in JEE Advanced. But there are some questions in JEE Main also from this particular concept, that is projectile on an inclined plane. Projectile on an inclined plane. Projectile on an inclined plane. Simple. Okay, so there is an inclined plane like this, and a particle is thrown like this. This is, suppose that angle theta, sorry, alpha, right? This is an angle alpha, and a particle is thrown with velocity. Suppose this is the ball, and this is thrown with velocity u at an angle with respect to this incline, at an angle theta, and this will go something like this. This will go something like this. This will go something like this, right? This will go something like this, and this velocity is u. Now, what is the difference between the projectile on an inclined plane and the basic projectile is, just listen to me very carefully, that in this section, in this particular kind of questions, there is two acceleration. Why I'm talking so? Because if a particle is placed on an inclined plane, there is two accelerations which are working on this particular particle, because g is what? G is always acting downwards. It doesn't matter. G doesn't given anything, that if you are throwing it like this, or on an inclined plane, on a horizontal plane, it doesn't matter for G. G simply says that I will act only downwards. I'll not change my nature because of your throwing skills, because of your bad throwing skills, right? So now what G will do is, G will simply be downwards. So this is theta. Now break this G into two components. This is what? This was alpha, sorry. This was this is like this. This is G, this is G, this is alpha, this is also alpha. So this is what? G cos alpha, and this is what? G sin alpha. G sin alpha, correct? Now listen to me very carefully, that in the previous case there was only G on the basic projectile, on the horizontal projectile, that was acting downward, and that whose magnitude was only G. But in this problem, there is two acceleration. One is acting perpendicular to the motion, and one second is, or we can say, perpendicular to the inclined plane, and other is acting along the plane, and along the inclined plane. Okay, so what we'll simply do, just break this u into two components, like we did earlier, that this is u cos theta and this is u sin theta, correct? Okay, now let us calculate the time period first of all. What in this section we just calculate two things, time period and range. So how we'll calculate the time period? Just see the beauty of this. Just see that the vertical component, and now you have to fix, now you have to shift your xy system according to these things. Previously x was this, y was this, ux, ui, we knew properly that what it is like generally. But in this particular section, x-axis is this, y-axis is this. So break your things according to this. Okay, now now don't think that I'm talking about that XY system. I'll simply talk about this XY system in this particular example. So please remember this. Okay, now first of all we'll calculate the time. So how we'll calculate the time? The final time is, sorry, final velocity on the vertical position, on the height, on the top of the Y will be 0 simply. Okay, now just remove all these things. I'll simply write these things here because that place is for the calculation. So this is G, sorry, this is G, this is what? G cos alpha, because this is alpha, and this is G sin alpha. Okay, so what is the acceleration in the y-axis? That is G cos alpha. And this, what is the acceleration in x-axis? That is minus G sin alpha. Just remember these things in your head. Now we have to calculate the time. So what is the final velocity? Final velocity is 0. Initial velocity is what? U sin alpha. And acceleration is what? Acceleration is what? Minus G cos alpha. Correct? Now apply the first equation of motion. That will be equal to V is equals to U plus 80. U plus 80. So V is 0. U is U sin theta minus G cos alpha into T. So what is the time? T is equals to U sin theta divided by G cos alpha. This is the time taken by this projectile in going upward. So this is the time in going upwards. So this will be the time in going downwards also, na? So total time will be what? Total time will be what? Total time T is equals to twice of this particular time, means 2U sin theta divided by G cos alpha. So this is the total time taken by the projectile to complete its motion. Now, if we have to calculate the range, now there is not the it was almost similar as the normal projectile, but in calculating the range we have to write the expression properly, and we have to keep this thing in mind also, that there is G sin alpha. So we can't directly apply distance is equals to velocity into time. We can't directly apply this. We have to apply the equation of motion. So if we have to apply the equation of motion, so we'll calculate the simply range. That range is equal to, or we simply range is equal to, what is the velocity in this x-axis? What is the velocity? That is U cos theta. So U cos theta into T minus half. What is the acceleration? That is G sin alpha. Remember, that was G sin alpha. So minus half GT, half G sin alpha into T square. Correct? Just substitute the value of time. So R will be equal to U cos theta into time is what? 2U sin theta divided by G cos alpha. 2U sin theta divided by G cos alpha minus half G sin alpha into what is T? Again 2U sin theta divided by G cos alpha to the whole square. Correct? Aligned? Totally aligned? Okay. Why 6 p.m. bacha? Is there any specific reason to change the timing? I can change. I don't have any problem. Okay. But tell me the specific reason. No. R is equals to U. Is there any cancellation? No. There is, look at this thing properly. U into U square. 2 sin theta into cos theta is equal to sin 2 theta. Sin 2 theta divided by G cos alpha minus. Is there any cancellation in this term? None. 1 2 is got cancelled with 1 2. 1 G is cancelled with 1 G, and we will be left with U sin 2U sin square theta into sin alpha divided by will be left with 1 G here and cos square alpha. Nothing else. Done. So this is the range. We can further simplify also, but no need. We can further simplify, but no need. Done. Okay, very good. Very good. So this was about the inclined plane projectile. People just think that it is too tough, but if you know the basics, bacha, if you know the basics, like if you know all these things, that how we can apply the equations of motion in these particular cases, there is nothing to worry about it. I guarantee you there is nothing to worry about it. Okay, hello Daniel, hello. So what I was talking about, yeah, I was talking about the motion on an inclined plane. Done. Now we'll furthermore, and let me tell you one thing, if you are new to this stream, that we are doing these chapters into two segments. In first segment, like in this session, I'm doing just theory with some little examples. But in the second session, I'll do all JEE Main PYQs of like from 2002 to 2024. In that particular session, that will be very long session, that can go up to 7 to 8 hours, but this will be small session, like 3 hours or 4 hours around. Okay, so if you are new to this channel, just subscribe, hit the subscribe button and click on the notify me button. Also notification, there is a notification bell, just click on that. And if you like this session or stream, just click on the like button also. Okay, and don't forget to share with your friends. Okay, then let's move on to the next thing. Let's move on to the relative motion. What is relative motion? Relative motion is something like, you are sitting in a train. Just imagine you are sitting in a train and you are just seeing that other things are just moving. You are seeing the train like this. You are seeing that just the poles like this. You're just passing. So for you, all the train things are at rest, but the outsider things are completely moving. So this is the relative motion. This is the relative motion. Like if you are in the train, so train is at rest for you. If you are outside the train, train is moving for you. So if you are sitting on any frame which is moving, now there are two kinds of frames. First of all, before talking to the relative motion, I'll talk about the frame of references. There is a term which is being used in these type of things, which is called the frame of reference. What is called? Frame of reference. Frame of reference. Frame of reference. So there are two kinds of frame of reference. First of all, let us understand what is a frame of reference. So frame of reference is a simple thing. Like if we are like seeing something from other thing. In Hindi, I simply say dekhne ka nazariya. If you understand Hindi a little bit, then there is a beautiful word for it, which is called dekhne ka nazariya. That from where you are seeing the things. Like if you are seeing from the moving frame, it will be like moving. The rest thing will be like moving for you. Like if you are moving, if you are sitting in a bus or a train or a helicopter, anything moving frame, if you are sitting in, then other rest thing will be moving for you. Suppose that you are sitting in a train and there is you're on a platform, and sometimes you feel that my train is moving because you say that there is a movement in the other train, but sometimes you realize that your train is stationary but the other train is moving. I hope you can relate with this, that you are stationary but the other train is moving and you feel that my train is moving, let's go. Right? So that is called the frame of reference, that from where you are seeing. So there are two kinds of frame of references. First is inertial frame of reference. Inertial frame of reference. And other is non-inertial frame of reference. Non-inertial frame of reference. What is the difference between these two things? If we are talking about an inertial frame of reference, it means we are talking about a frame which is, listen to me very carefully, if we are talking about the inertial frame of reference, it means we are talking about a frame which is either at rest or moving with a constant velocity. Just remember these two things about the inertial frame of reference, that either it is at rest or it is moving with a constant velocity. So it is either or rest or moving with constant velocity. This is the inertial frame of reference. Now let's talk about the non-inertial frame of reference. What is the non-inertial frame of reference? If you talk about this, just listen to me very carefully. It is something like which is not moving with constant velocity. It means it has some acceleration. Like if you are sitting in a bus which is moving with constant acceleration, which is moving with constant acceleration, like sometimes it is like you are doing like this, sometimes doing like this, it just starts suddenly, it just stops suddenly. So that kind of frame is called non-inertial frame, which is not moving with a constant velocity. So it is not, yeah, moving with acceleration, moving with acceleration. Okay, just remember these things for the future, and we will mainly talk about the inertial frame of reference in this segment. In this relative motion, we will be talking completely about the inertial frame of reference. Yeah, but in some times, like in the shortest path or in some relative motion type something, in relative projectile motion something, we can also talk about the non-inertial frames also, because there can be some there can be some acceleration also. So mainly we'll be talking about the inertial frame of reference. Okay, got it? Done. Okay. So if we are talking about the inertial frame of reference, let's talk about the relative motion like this. So if suppose that you are sitting on in a car. If you are sitting in a car, then this is you, and car is moving with velocity something b. You are a. So your car is moving with velocity a, and you are moving on the track. And there is a footpath also. And on this footpath, this footpath, let me make this footpath very good. So on this footpath, a girl was passing something. Suppose that a girl is passing on the footpath. Clear? Okay, 12th 2025, this batch is also has some major portion about 2025. Let's talk about it later. So suppose that a girl is passing on the footpath, and you are moving with velocity va, and girl is moving with velocity vb. Girl is moving with velocity vb. Done. Now you just saw the girl, and you just wanted to calculate the velocity of, calculate the velocity of the girl with respect to yourself, so that you can realize that it is falling behind, or it is going forward. So you just want to calculate the velocity of that girl with respect to yourself. So we'll simply say that velocity of that girl with respect to you means a, that is equals to velocity of b minus velocity of a. This is the expression of relative velocity, and it has lot of things in it. And one thing you have to remember, that velocity of a with respect to b, it has two things. First of its magnitude, and second is its direction. Similarly, velocity of b has two things, magnitude and direction. Similarly of a also. So there are three things in this expression, but there are three hidden things also in this particular expression. Okay, so three are the magnitudes and three are the directions. So it has six things: magnitude, direction, magnitude, direction, magnitude, and direction. Okay, so suppose that we have two vectors, vector a and vector b, and we have to calculate the resultant of the vectors. So we simply write c vector is equals to vector a plus vector b. So this is the same thing like this. That we have to calculate the resultant of v of, or we can say the resultant of v of b, velocity of b, and the negative of velocity of a. Correct till here? Okay. So we have realized there are six things in this particular expressions. Three are the magnitudes, three are the particular directions, right? So if there is certain kind of questions in which there is some resultant, I'll show that how what kind of questions are being asked, what type of patterns they can follow. So there are six things, and they will give minimum four things. Minimum four things will be given, and you have to calculate, calculate the rest of 2. ऐसा मैं देखो, see, let us discuss that. Why I'm saying so? That minimum 4 things he will give to you and 2 things you have to calculate, because you have 2 equations hidden in this particular expression. If you are saying that this vector C is the resultant of A and B, it means there are some hidden things in this particular expression. What kind of hidden things? That suppose that the angle between A and B is theta, so we can also write the magnitude of C in terms of A, B and theta, and that is written as the magnitude of C is equals to under root A square plus B square plus 2AB cos theta. This is the first thing. This is the first equation we know. Other, if this is C and it is making alpha angle with A, so we can simply write tan alpha is equals to just a second, we can simply write that it is equals to B cos theta, B sin theta. I hope you remember this expression, B sin theta divided by A plus B cos theta divided by A plus B cos theta. So these are the 2 equations. First is this and the other is this. So you have 2 equations, and one thing you have to realize that if you have 2 equations, you can calculate only 2 variables from the 2 equations. This is the basic mathematics from the class 9th 10th, that if you have 2 variables, you need at least 2 equations to solve those particular 2 variables. Agreed? Yes or no? Please write in the chat section if you agree with this, that you have been given 4 variables and you have to calculate 2 variables, then you need at least 2 equations to calculate those 2 variables, right? Okay, now how he will give the variables to you. Suppose that, first of all, I hope you all know the directions like north, south, east, west, right? So let me quickly recap it. Like, this is north, this is south, this is east, this is west, right? Suppose that it is saying that the particle is moving 30 degree to the north of south. Suppose that it is saying 30 degree to north of east. Suppose that north of east. If it is saying north of east, it means you have to start from east. What is it in last? You have to start from there. So if it is saying that 30 degree to north of east, means you have to stand first of all at east, and then you have to move towards north by 30 degree. So you just move 30 degree. So this is the direction. This is how he gives the direction. Agreed? Yes or no? Chat section is only for you guys. Okay, suppose that it is saying that 45 degree south of west. Can you write in your notebook 45 degree south of west? South of west means we have to start from the west. Correct. We have to start from the west and we have to move 45 degree towards south. So this will be the direction. So if you have to calculate any direction, you have to understand that how it is giving to you. Clear everything? Now we'll move on to the next thing, and there is very interesting thing that comes under relative in 2D. Relative in 1D, just one expression, velocity of B is with respect to A is equals to velocity of A minus velocity of B minus velocity of A. But the thing is majorly questions come from relative in 2D. But I'll tell you one thing, that most of the questions in kinematics comes from the that motion and the gravity motion. From this section, there is rarely 1 or 2 question that comes from here. So you just need to understand this thing, and we'll proceed. I'll just explain these things to you. I'm not going to take the PYQs or the questions in this section. I have already told you that this section is dedicated for the theory section, and in the next session next week we'll do all the PYQs, all the questions of the kinematics from 2002 to 2024 on this particular channel, which is called Unacademy JEE English. And don't forget to hit on the subscribe button. Yes. Okay, so in relative in 2D, there are 5-6 kind of questions which are being asked generally. These are the major questions which are being asked generally. So first is closest distance questions. Means suppose that a particle, I'll explain. First of all, I'll just take you a brief recap that there is a closest distance motion or closest distance questions, that two particles are moving, and you have been asked that what is the closest distance between these two particular particles. So this kind of question. Second is relative projectile. Means two projectiles are there. These two projectiles are there, and you have to calculate the that when they will meet, or when they will like collide, or what is the time of flight with respect to this, for this kind of questions. Third is these sections, relative boat, river boat, plane wind, rainman, flag flattering, all these things comes under the same category. So I'll just explain one of them very briefly, and you will be able to solve each and every problem of this. We'll show you in the PYQ session that you are able to solve each and every problem. Okay, clear? Okay, now first of all we will move on to the closest distance problems. Closest distance problems. Closest distance you have to find. Correct? Now how you will find? Suppose that there are two particles. One is this, one is this. Okay, this is at rest, and this particle suppose that is moving with this velocity. Suppose the distance between these two particles is 40 meters, and it is being projected at 53 degree with velocity 5 meters per second. 5 meters per second. Now you have to calculate the closest distance between these two things. Now don't think that this is a projectile. I've already said that projectile is a different aspect of this, but this is if you will throw like this, if you will throw it like this, it will simply go like this. It will not be like this. Okay. So how we'll calculate? You have to understand one thing, that suppose that this is a point and this is a line. What is the closest distance between this line and this particular point? What is the closest distance? How you will calculate? You will simply drop a perpendicular from that particular point on the line. You will drop a perpendicular on the line. That perpendicular will be the shortest distance between that point and that particular line. Agreed? Now, in this particular case, how you will calculate? You will simply say that particle will go something like this. And we will drop a perpendicular on it. So this will be the closest distance. Now what? You know this distance. This is 40. This is 40. This is what? Take this 50. Take this as 50. It will be easier to solve. So this is 50 meters. This is 53 degree. Can you calculate this? Can you calculate? Simply you can calculate. So this is what? This is the hypotenuse. This is the base. This is the perpendicular. So this is what? Sine 53. Suppose that this is x is equals to x by 50. Sine 53 is what? 4 by 5. So that is equals to 40. So x is equals to 40 meters. So the distance, the shortest distance between these two particles is not 0, acha. That is 40 meters. That is 40 meters. Correct? No problem. Okay, just take the benefit of these sessions. Okay, so this is what? 40 meters. Now. Suppose that this particle is also moving. Take this example. Suppose that this is particle A, this is particle B, and this particle is moving. This particle is moving in this direction, and this particle is also moving in this direction. There is starting distance is 50 meters. Suppose that this angle is suppose that 37 degree, and this is what 53 degree. This is what 53 degree, and this speed is also this is also suppose that 50 meters per second, 50 meters per second, and this is given as 100 meters per second. 100 meters per second, correct? Totally aligned with it? Okay, boss. Okay, now we have to calculate the shortest. Now this is a good question. So how we will calculate the shortest distance between these two particles? First of all, break their components. This has something 100 meters per second velocity at 37 degree. So break it. This will be what? 100 cos 37. So 100 cos 37 is what? 4 by 5, correct? Solve. Do calculation yourself, not see my calculation, just solve it yourself. And one more thing I also want to tell, that first of all understand the things, then you can note it down. I can also give the PDF in the telegram channel. Okay, so 20, this is 80 meters per second, and this is what? 60 meters per second, and directly I will solve. Okay, 60 meters per second. Now break it down. This is what? 50 cos 53 means 30 meters per second, and this is what? 40 meters per second. 40 meters per second. Now, when will be the closest distance between them? How we will calculate the closest distance between them? So first of all, we have to sit on this particular particle. We have to sit on a particle and see what other particle is doing. Suppose that sit on this particular particle. You have just sit on this particular particle, and now you are watching this particle to become. Okay. So when you are on this particular particle, this particle is at rest for you. This particle is at rest for you. So this particle is at rest. If this particle is at sorry. If this particle is at rest, then what this particle is doing for you? Its velocity is 30. Its velocity is 80. So what will be the relative velocity of it? What will be the relative velocity of it? Will it be 50? Directly I will write, or suppose that this is A, this is B. I'll simply solve it. Okay, don't worry. I'll do it step by step. So velocity of B with respect to A is equals to velocity of B minus velocity of A. Both are in the same direction. So just simply write velocity of B is 80 minus velocity of A is 30. Okay, 50 meters per second. 50 meters per second. Okay, boss. Okay, boss. So this is what? 50 meters per second. This is what? 50 meters per second. Now, you are sitting on this. You are watching this. So what is this? Directly I will write 20 meters per second, because this is 40, this is 60. This will be 20 meters per second. 20 meters per second. Now can you calculate the resultant? Now this is the previous problem. Now this is the previous problem where this particle was stationary, this particle was moving, and there was the velocity. Similarly, this particle is at rest, this particle is moving. So its resultant velocity will something like this. Agreed? This distance is what? This distance is what? 50 meters per second. Can you calculate this angle? Because angle is the most important thing. Can you calculate this angle? This angle is what? Suppose that this angle is theta. So we can simply write tan theta is equals to 20 by 50. So this data is, I don't remember any data. I don't take any data like I have remember. So I just made the problem in front of you. You have just seen that how the problem is being solved. Because if you know this angle, suppose that this angle suppose that comes out to be something 30 degree. Suppose that 30 degree. So if this, we know this particular distance, you just extend this, make this is 90 degree. You have to find this, x by this is equal to sine theta. You have just found the x. 0 meter? No, Ashwath, that is not 0 meter, bacha. Correct? Agreed? So this is how you can calculate the shortest distance. Now let's move on to the next thing. Which was the relative projectile. Which was the relative projectile. How you will solve relative projectile? Suppose that these are two particles. Suppose that this is thrown, this is also thrown, this is at angle 37 degree, this is at angle 53 degree. I'll just keep it very clear. I'll just make the figure very beautiful because my drawing is very good. this, take the data something 10 meters per second at 37 degree, 53 degree, 20 meters per second, 20 rupee momo, 20 rupees momo. Have you seen that particular meme? Don't watch the meme actually. I don't encourage you to see the memes. Okay, so I'm sorry. Okay, let's solve this. So 10 meters per second, 37 degree, 20 meters per second, 53 degree. Okay, first of all, what we have to do is we have to calculate when they will collide. When they will collide. When they will collide. How we will solve this particular section. Now, just break into the pieces like components. So this will be what? 10 cos 37. 10 cos 37 means 10 into 4 by 5 means 8 meters per second. So this is 6 meters per second. You can solve now. This is 10 sin 37 means 10 into 3 by 5 means 6. Okay, similarly this is what? This is 10 sin 53. Sorry, 20 sin 53. 20 sin 53 means 4 by 5 means 16, right? 16 meters per second, and this will be 12 meters per second, I hope. Okay, okay. But it is not necessary that they will collide. It is not necessary that they will collide. So just we have to change that data because listen, understand it. Suppose that these are two particles. These are my earbuds. I am taking the risk because of you. So just think. Suppose that I have these two earbuds and I just throw it simultaneously. I just throw it simultaneously at any random angles and any random velocity. So it is not necessary now that they will hit. It is not necessary that they will hit. So I have to calculate a certain velocity that they should hit. Agreed? Yes or no? Please write in the chat section. Please write yes or no. That they certainly do not hit at any random velocities or any random angles. We have to select the velocity. If we are selecting the angles, suppose that I don't know this velocity. Suppose that I don't know this velocity. Suppose that this velocity is u. This velocity is u. Now we have to select this u such that they should collide. Now this is the problem. Now this is the problem that you have to find u. This is the basic problem. Find u such that they collide. They collide. Agreed? Yes or no? Please write in the chat section. So u, the component of u is in this direction. U cos 37 and cos 37 is 4u by 5 and this is 3u by 5. Correct? Now. Suppose that you have a target. Suppose that you have a target and you don't want to miss it. Target is fixed. That there is a girl standing in front of you and you have to approach her. You have to go to her. What you will do? You will, if she is standing right there, what you will do? You will move in this direction? No, na? You will simply move in this direction so that you can approach her, you can go to her, right? Now, listen to me very carefully. It simply means your direction of velocity should be towards the point where you want to go. Agreed? So first of all, if that is at rest, your velocity should be at that particular point. So make this at rest. Suppose that you just sit on this particular particle, so it will be at rest. So if you want to make this at rest, you will have to sit this and you just have to calculate these velocities with respect to this. So just calculate this. So this was at rest. So what will be it? This is 4u by 5, this is 12, and these are together because direction is opposite. So we'll just add, and this velocity will be 12 plus 4u by 5. This distance is suppose that 100 meters, and this will be what? This is 16, and this is 3u by 5, and they're in the same direction. It means 16 minus 3u by 5. Correct? Now now, just imagine this thing. You are here at this particular point. This is the girl standing where you want to approach. Now what you will do? If you approach like this, if you approach with this velocity, you will certainly go to her. Otherwise, if your velocity is in any random direction, you will never get to her. Agreed? Yes or no? Please write in the chat section. Now, suppose that there are two kind of velocities. One, you have to reach this particular point. There's velocity in this direction. There's velocity in this direction, as shown in the figure. So there will be a resultant velocity in this direction. There will be a resultant velocity in this direction. So if a resultant velocity in this direction, you will ever reach to her? No. So it means your velocity should be only towards her. It means this component should be 0. This component should be 0. It means 16 minus 3u by 5 will be equal to 0. 16 minus, where should I write? I am writing here. 16 minus 3u by 5 is equals to 0. It means u is equals to 80 by 3. Calculate it. 16 by 80 by 3. 80 by 3 meters per second. 16 by 3 meters per second. Correct? Aligned? Totally? So this is the velocity of this particular particle. Now, second question can arise that when they will meet. That I asked initially, that when they will meet. Now you know what is the velocity, what is the value of u. If you know the value of u, you can put it here. You can substitute here, and it will be 12 plus 4 by 5 into u is what? 80 by 3. Means 16 4s are 48. Ganda sa data, bad data. So it is what? 12 plus 16 4s are 64, sorry, 64 divided by 3. So this will be a bad data. I'm not going to solve it properly, but I'm going to tell you that how to solve it. 12 plus 16 by 3. Now this is the velocity. Now you have to reach from here to here. This is the distance. This is the velocity. How you will calculate the time? Time is equals to what? Speed. Time is what? Displacement. Speed upon displacement. Speed upon displacement. Speed is what? This. 12 plus 16 by 3 divided by 100. This will be the total time taken by this particle or this man to reach this girl. Done. Okay, Arush. Okay, great. You can watch the recording session also for the further discussion. Let me tell you, if you are first on this live stream, then let me tell you one thing, that we are doing two things in this series. That we are covering all the major theory portion in one stream. Like in this stream, I'm completing theory. I'm almost about to complete this session, and next session will be on the PYQs. In that particular session, I will complete all the PYQs from 2002 2024 in that particular session, and that session is going to be rocking. You'll just enjoy that session. So if you don't know the theory, if you don't know about the basics of the kinematics, you can watch the recorded session of this particular segment. Okay, then you can also join the PYQ session. Okay, great. Okay then. So this was all about relative projectile, right? Okay, let's move on to the next thing. No, don't all the best. No, all the best. Just move on to the next thing. That is what? Riverboat problem. This is the last segment. Riverboat problems. JEE Main doesn't ask that many questions from riverboat problems. They just ask very simple problems from this. So I'll just explain how this works. Okay, boss. Come to this. Suppose that there is a river flowing like this. Okay, and suppose that the velocity of river is remember one thing, that how to erase this? Yeah. So this is the velocity of river. And a man is trying to swim in a particular direction. Suppose that there is a man who is trying to swim in this particular direction. who is trying to swim in this particular direction. There are three things, bacha. That velocity of, yeah, there is a boat also. Man, don't think about the man. Suppose that a man is trying to swim his boat in this particular direction. So there is a direction of this, but just listen to me very carefully. Will the boat go in this direction if he is trying to just row his boat in this particular direction? Will it go in this direction, or that will go in the some other direction? It will certainly go something in this direction, because he is trying to do because of the stream of the, because of the flow of the river, it will not go in this direction, it will go some other direction. So there are three things, bacha. First is the velocity of river, that is being given, that is the direction of also given. Second is velocity of boat. We have three things: velocity of river and its direction, velocity of boat and its direction, and velocity of boat with respect to river and its direction. So first confusing things for all the students is in these two things. In one direction he is trying to go, and in the other direction he is actually going. Which one is velocity of boat with respect to river, and which one is velocity of boat actual? Can you predict? Can you predict? But in the sessions, I've seen that most of the students say that in the direction he is trying to go. Listen to me very carefully. In the direction in which he is trying to go, that is the velocity of boat. That is the velocity of boat. But the other is velocity of boat with respect to river. But that is not true. In the direction where he is trying to go, where, just write these things in your notebook. That is very careful. Be very careful with this. Where he is trying to go, where he is trying to go, that is VBR. That is VBR. Or he can simply, or there are other terms which are being used for VBR. If he is saying that the engine speed is something 20 kilometers per hour, if he is saying about the 20, first of all let me explain this. If he is going in the if he is trying to go in a particular direction, why I am saying that is VBR, why it is not VB? Because actually he is going in this direction, and if you are standing on the ground, you will simply see that the man is going in this direction, or the boat is going in this direction. So I will not say that this is the velocity of boat with respect to the, because this is from the ground you are seeing na, that he is going in this direction. So that is the velocity of boat. So this is the velocity of boat, and this is the velocity of boat with respect to river. Clear? Agreed? So now listen to me very carefully. So if he is saying that this is the boat is trying to go in this particular direction, that is VBR. If he is saying engine speed is this, so engine speed also comes under VBR, because he is trying to flow with this particular speed, but he is flowing with this particular speed. So that is also VBR. You have the formula VBR, that is equals to VB minus VR. Velocity of boat with respect to river is equals to velocity of boat minus velocity of river. We just, like I have already given to you, that in these things there are 6 things, like VBR, magnitude and direction. In these 2 things, magnitude and directions. So there are total 6 things in this expression. We will be given with 4. We will calculate the rest of 2. I've already told you. So this is all about the river boat problem. You have to understand these things. We'll do the problems of this particular type also in the next session, in the upcoming session, in the PYQ session. In that, you will be thinking this is on river boat problem. Rain man problem also comes under the same category. I'll say in the explain things in that. So there is no need to explain that thing. Umbrella, that rain man problem, that umbrella wala problem, and other flag flattering. That flag is flattered in the air. So that is also comes under this. So these are plenty of problems which we can do in our segment. So this was all about the kinematics theory portion. I have completed all the theory portion in this particular session. In the next session, I will do the complete PYQs from 2002 to 2024, all the PYQs in that particular session. So I hope you all have found it very well. You enjoyed this session. If you enjoyed this, please hit the like button, and if you are first on this particular channel, please don't forget to subscribe this channel, and don't forget to hit on the notify me button. Okay, so you can get the notifications also. Okay, so see you in the next class. Okay, Yes. Okay, so see you in the next session. If you are in doubt, you can write in the chat section. Otherwise, see you in the next session. Okay, I'm ending the stream.